20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
Okay, we got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Plus 30 seconds. Altitude's 2 miles.
Oh, well, Houston, you're good at 1 minute.
Downrange 1 mile, altitude 4 miles now.
The moon hoaxers are often associated with flat earthers, that is, retarded, uneducated, scientific people. The media describe them as people who don't have education enough to comprehend the moon missions, who contest them with simplistic, easily debunkable arguments. This may be true for the flat earthers, who often do not have good arguments for the moon hoax, which ones effectively are easily debunked by the Apollo believers. But the serious moon hoaxers are completely different, and don't match with this description. The serious moon hoaxers find the idea of a flat earth completely ridiculous, and wonder why this idea, which has already been debunked for centuries, is popping up again. If the flat earthers turn around Antarctica, they will see that its perimeter is much shorter than the so-called ice wall which borders the flat earth. And, in the model of the flat earth, the sun could be seen from any point of the earth at any moment. In the model of the flat earth, if someone was going from the center of the earth to its edge, it would progressively become more and more bent because of gravity. You know, flat earthers, gravity, this property which makes that when you drop an object, it falls down on the ground. And the phases of the moon and the shape of its crescent can only be explained by a spherical moon orbiting the earth. The flat earth model does not explain either the lunar eclipses. If the flat earthers don't understand why, if the earth is spinning at a surface at a speed which is more than supersonic, we don't feel it. It is because they don't understand the difference between tangential speed and angular speed. They don't understand the notion of relative speed, and they also don't understand that a constant speed does not produce a force, while an acceleration and a deceleration do produce one. Of course, the serious moon hoaxers understand all these physical principles. And the seasons can only be explained by a tilted Earth orbiting the Sun. And of course, the serious moon hoaxers don't deny the satellites either. How would GPS work without satellites? And a parabolic antenna only receives a signal when it is exactly orientated towards the geostationary satellite. It could not work that way with relays on the ground. The serious moon hoaxers are also evolutionists and reject creationism. They know that the Earth is billions of years old and laugh at the idea of a 6,000 years old Earth. And they find the Creation Museum completely ridiculous and childish. They absolutely don't contest the accepted conception of the universe, that all the planets are spherical, or almost, including of course the Earth. Then why do they contest the moon landings if they accept the modern conceptions of science? Simply because these moon landings have absolutely nothing to do with the modern conception of science. Questioning these moon landings is simply wondering if, given the extraordinarily difficult situation of landing on the moon and surviving on it, and also surviving to radiations, the technology of the 60s was ripe enough in the 60s to allow these moon landings to succeed in less than a decade, at the first time and repetitively. And the more you know the project, the more you start to have doubts. And having these doubts does not make you unscientific at all, especially since the more you have a high training in this domain, and the more you see problems which may not appear to people who do not have this training. People often have absolutely no idea of the difficulty of landing on the moon in a void environment. They view it a little like a helicopter landing on Earth, while it has absolutely nothing to do with it. And they do not either have a good idea of the difficulty of surviving in an environment as difficult as the one of the moon, and they tend a little to see it as some sort of holiday camp. They are not at all surprised that the astronauts behave in a foolish way, despite the dangerous environment in which they are. This film is going to show that things are not as simple as some think, and that there really is good reasons to doubt the moon landings, even if you have a completely scientific attitude which has nothing to do with the belief in something as stupid as the flat Earth. Around the Earth there are radiation belts which have been named by the scientist who discovered them, Van Allen. These belts contain radiation which are dangerous for man, especially in the heart of these rings. Some think that once these belts have been passed there is no more danger, but it is completely wrong, for these are not these belts which create radiations. The radiations in fact come from solar eruptions, and these belts stop them and protect us from them. After these belts have been passed, there is no more protection against these radiations, so the danger persists. It depends of course on the current level of the solar eruptions. This is the table of the occurrences of the solar eruptions for the various Apollo missions. Robert Bray-Unick has imagined a trajectory that the command module would have taken, and which would have allowed it to avoid the dangerous part of the Van Allen belts and would have spared its radiations to the astronauts. This trajectory had been shown by many Apollo believers like it was gospel, and nobody doubts that the command module really took this trajectory. The problem is that there is not the least document of the time of Apollo which confirms this trajectory, and, still worse, there is even a document which outright contradicts it. This document, which contradicts the trajectory of Robert Bray-Unick, is entitled Apollo Launch Windows. This document shows the trajectories which would have been taken by the Saturn rocket. But what really interests us is the trajectory the command module would have been put on. The document clearly states that this trajectory depends on the position of the moon on its orbit. This position is not constant, and while the command module travels, the moon travels on its orbit. So in order to optimize the trajectory and make the minimal maneuvers, the goal is to direct the command module not towards the current position of the moon, but towards the position it will have when the command module has reached it. The moon orbital plane makes with the elliptic plane, the plane of the orbit of the Earth around the Sun, an angle of 5 degrees, which is to be added to the angle then the elliptic plane makes with the equatorial plane of the Earth, which is 23 degrees. So in total, 23 plus 5 equals 28 degrees. The document shows a graph which represents the direction of the moon relatively to the equatorial plane of the Earth as a sine wave of amplitude 28 degrees, the angle between the orbital plane of the moon and the equatorial plane of the Earth. That is why it's important to study the evolution of the moon on its orbit in order to determine the optimized trajectory, the one which will direct the command module directly to the position that the moon has when the command module arrives near it. So, the whole problem is to know where the moon will be on its orbit at the moment when the command module reaches it, in order to determine the direction it must take at the beginning of its travel. We know that the command module of Apollo 11 reached the moon on July the 19th. In order to know it, we have to look for the previous new moon and the previous apogee, so to be able to determine where it was on its orbit at this moment. And when we check it, we can see that the new moon preceding Apollo 11 happened on July the 14th, so 5 days before the command module reached the Moon. And when we check the apogee for preceding Apollo 11, we find that it happened on July the 13th, for 6 days before the command module reached the Moon. We know the Moon takes 7 days to travel a quarter of its orbit. From what we have just seen, it means that the Moon was at the moment much closer to the equatorial plane of the Earth than the peak of its orbit. It means that the angle that its direction was making with the equatorial plane was consistently less than the angle between the orbital plane of the Moon and the equatorial plane of the Earth, hardly a quarter of it. In fact, the SIVB was not only given an initial speed to the command module, allowing it to get away from the gravitational field of the Earth, but also an initial direction corresponding to the position that the Moon would have when it would reach it. When the command module was just following this direction with its engine off, and was making no change of direction before the point of the first mid-course correction. In Apollo 11, the point of first mid-course correction was at a very low latitude, which means that it was quite close to the equatorial plane of the Earth. If we draw lines between the point that the command module left the SIVB and the point where the command module reached the point of the first mid-course correction, without having to use its engine between these 2 points, in the various missions in Apollo, using the data we find in the mission reports, it gives what this animation shows. You can see that the command module systematically goes into the heart of the radiation belts. It never tries to avoid them. If the command module had tried to take the trajectory advocated by Robert Brownlee, it would have had to consume plenty of propellant to make all the changes of direction, and it would have burnt so much of it, it would have been short of it even before reaching the Moon. It was completely contrary to a reasonable consumption of the propellant. If the astronauts had gone around the Van Allen belts, perhaps they would have been spared the radiation, but they would not have had enough propellant to come back to the Earth, and they would have ended up lost in space, which is hardly better than not suffering from radiation. NASA has shown tables of re-entry parameters for the various missions. The flight path angle is the angle under which the spaceship penetrates into the atmosphere. It is obvious that the greater it is, and the faster the command module will descend. However, this angle must not go beyond some limit, otherwise the descent speed would be such that it would cause fatal overheating for the command module. The re-entry parameters are not easy to study when directly read in the table. That is why they have been here represented in the form of supposed graphs. For each graph, the lowest ordinate coordinates to the minimal value of the parameter, and the highest ordinate to the maximal value of the parameter. The horizontal axis corresponds to the missions Apollo 11 on the left to Apollo 17 on the right. The Apollo 13 mission, corresponding to the blue vertical bar which has been represented, is particularly interesting. It has a greater flight path angle than in the previous missions. It also has a smaller duration, which is logical, for this greater flight path angle made the command module descend faster. But while it should have also had a greater maximum g measures the acceleration or deceleration, greater heating parameters and also higher radiation dose than the previous missions, it illogically appears to be the converse. All these parameters are varied in the wrong direction. And if we compare Apollo 11, left of the graph, with Apollo 17, right of the graphs, we can see that Apollo 17 has a consistently smaller duration than Apollo 11, which means that it's descended faster, greater heating parameters and greater radiation dose, which is compatible with a faster descent. But while we'd expect Apollo 17 to have a greater maximum G than Apollo 11, it illogically has a little smaller one. We can find other incoherencies in this table which cast a serious doubt on these re-entries. Then you are going to say, if the command module did not return from space, then how is it that we could see it go down with its parachutes? It was simply dropped from a cargo plane flying at high altitude over the clouds. It was dropped like in this test. You can notice that in this test the parachutes are dropped in the same time as the command module. They don't deploy from the module. If the parachutes could deploy from the module, then why didn't they show it in this test? and we can wonder how so big parachutes could hold in so small compartments. In the videos of Apollo, the spaceships behave in a completely abnormal way. For instance, in this sequence of Apollo 15 filmed from the lunar module, we see the lunar ground which shifts completely fast and slow, which suggests that the orbital speed of the command module and the lunar module would change in a completely impossible way. And in the videos and photos of Apollo, while the command module and the lunar module are flying one above the other for some time, before the lunar module starts its descent on the moon, it is the lunar module which is above the command module, while we would rather expect the converse. And on this photo of Apollo 11, AS11 37 5447, we can also see the command module, which is far under the lunar module. And if we make a close-up on it, we can effectively see that is the command module. But why the command module have gone so far under the lunar module? It is absolutely obvious that the nozzle of the service module was lighter than the rest of the command module. This fact will place the centre of the mass of the command module above its geometrical centre when it is orientated up. When the centre of mass and the geometric centre of the satellites are not confused, this satellite naturally orientates itself so the centre of mass and the geometric centre are aligned with the direction of the centre of the body of the satellite's orbit, whether it is the Earth or the Moon, and the centre of mass closer to this body. This comes from a physical principle called gravity gradient, and it is explained by the fact that the gravitational force varies with the inverse of the square of the distance of the satellite to the body's centre, while the centrifugal force varies with the simple inverse of this distance. Consequently, when the satellite gets away from the body, the gravitational force decreases faster than centrifugal force. It means that if the centre of the mass of the command module is closer to the cone of the command module than the geometric centre, the command module should naturally orbit the moon so that the cone of the command module is orientated downwards and not upward. So the command module should not orbit the moon this way, like what we see on the videos. But this way, with the cone of the command module orientated towards the moon. Of course, these animations are symbolic and respect neither sizes nor distances. Now you understand why it was the command module which had to be under the lunar module and not the opposite. On this animation made for the successive photos of Apollo 14, we can see the lunar module, which wildly turns over as it gets away from the command module. Of course, it could turn over so that the pilot of the command module could inspect it before it starts its descent on the moon. But it should then remain close to the command module while it turns over, and not get in the way at the same time. What we see here is completely illogical. Some have compared the lunar module with a plane or a helicopter, but its behaviour is completely different from the one of a plane or a helicopter. Indeed, the lunar module has no wings, which would be completely useless in the void of the moon. While a plane passively uses the force of air to control its attitude and to sustain itself in the air, the lunar module controls it actively with its engines, and the control is extremely different. The lunar module was initially too far from the lunar surface to start the powered descent, so it is starting to take a descent orbit to reach an orbit closer to the lunar surface from which it could start the powered descent. This manoeuvre was consisting in decreasing a little its orbital speed in order to put itself in an elliptical orbit, allowing it to reach this closer orbit. This manoeuvre was called DOI, Descent Orbit Insertion. After the initial manoeuvre, the lunar module was just gliding in this orbit with its engine off. In this sequence of Apollo 12, we can see the lunar module making this manoeuvre. We can be sure that it is currently reducing its orbital speed, for we can see the lunar horizon appear at the end of the sequence, the black which appears over the lunar ground. It means that the camera of the command module is turning to follow the lunar module getting away from it. So, if the camera of the command module turns to follow the lunar module, it means that it should see it under a different angle. Yet, on this video, the camera keeps seeing the lunar module under the same angle, like the lunar module was still at the vertical of the command module. This sequence is thus unrealistic. When the lunar module has reached a closer orbit, it starts the powered descent, which means that it's going to use its engine at full thrust initially. During the initial phase, the lunar module is orientated horizontally because it must use the thrust of its engine to counter the horizontal velocity and make it decrease. Initially, the centrifugal force allows the counter the lunar attraction, which means that it does not need to be countered. Progressively, as the LM loses its horizontal velocity, the centrifugal force decreases, which means the lunar attractions tend to be more and more attract the lunar module towards the moon and make the vertical speed increase. But during the initial braking phase, the vertical velocity remains small relatively to the important horizontal velocity and represents only 1/100th of the horizontal velocity or around it. So in this phase, the lunar module ignores the lunar attraction and concentrates the thrust of the engines, essentially decrease the important horizontal velocity, which means it remains horizontal. After this phase, it starts turning to vertical in order to start countering the lunar attraction before the vertical velocity becomes too important. Moderately at first, and then more and more as the horizontal velocity becomes smaller and smaller, to end up completely vertical at the end. This change of attitude must be very progressive and can in no way be brutal. When the lunar module is close to the lunar surface, its horizontal speed is very moderate. If it was not, there is no way the landings could have succeeded, and the lunar module could not benefit any more than centrifugal force, and it must counter the lunar attraction with its main engine. If it was turning horizontal at that moment, it would be attracted by the moon and crash on it. The physics of the Ascent is exactly the same as the lunar module, but inverted. It has to turn slowly and regularly from a vertical altitude to a horizontal one, to leave the time of the centrifugal force to grow enough to be able to sustain the lunar module in space. This sequence, in which we see the lunar module suddenly turn from a horizontal attitude to a vertical one just before landing on the moon, makes absolutely no sense, for when the lunar module is close to the lunar surface, it has a low horizontal speed and has lost a centrifugal force which was allowing it to counter the lunar attraction, and it does not benefit of air force to sustain it, like for a plane or a helicopter on Earth, which means it can only counter it with its main engine, and it must absolutely have a vertical attitude for its main engine to counter this attraction. Its lateral engines allow it to make for maneuvers of rotation and translation, but they are not powerful enough to counter the lunar attraction, and moreover their thrust cannot be adjusted. If the lunar module was flying with a horizontal attitude, it would not be able to counter the lunar attraction, and it would be attracted by the moon and would crash on it. And even if the lateral engines had been powerful enough to counter the lunar attraction, and their thrust could have been adjusted exactly to counter the lunar attraction, the lunar module would not have been able to remain perfectly stable like what we see on the video, when it is turned from a horizontal attitude to a vertical one. So, this video does not make the least sense. It is physically impossible. In the liftoff of the lunar module from the moon hoaxers have criticised the fact that we cannot see the plume of the Ascent engine. The Apollo believers think to have found an explanation for it by saying that the composition of the propellant is such that this plume is invisible. In this case, the Apollo believers would have to explain why this plume can be seen on the lateral thrusters in another sequence of the film, while these thrusters use the same propellant as the Ascent engine. When the lunar module reaches the top of the image, we can see that it makes a sudden pitch over, that it is passing from a vertical attitude to a horizontal one. This is outright impossible. The lunar module cannot pitch excessively that way. It has still not reached the necessary horizontal speed which will allow to counter the lunar attraction, and therefore it cannot currently take a horizontal attitude. When the Saturn rocket is raising in the air, we never see it pitch that way. It pitches very slowly, progressively. If it had pitched like the way we see the lunar module do on the video of its ascent, it would have fallen back on Earth and crashed on it. This simplified schematic illustrates what happens when a rocket is launched. The rocket thrust has been represented with the yellow arrow, the gravity with the red arrow, and the gradually appearing centrifugal force with a green arrow. When a rocket is launched to be put into orbit, it first ascends vertically to extract itself from Earth's gravity and gain vertical speed. Then it starts turning to a more horizontal attitude to start gaining horizontal speed, but not brutally, but very gradually instead. It first takes a moderate horizontal attitude, which allows it to gain horizontal speed. As it is gaining horizontal speed, a centrifugal force starts to appear, and this centrifugal force helps the rocket to counter Earth's gravity. So the rocket turns a little more horizontal, which allows it to gain still more horizontal speed. As the horizontal speed increases, so does the centrifugal force, which helps the more the rocket to counter Earth's attraction, which allows the rocket to turn more horizontal to gain still more horizontal speed, and so on. At the end of the process, the rocket ends in a completely horizontal attitude. Its horizontal speed is now the orbital speed, which allows to create a centrifugal force which is exactly equal to Earth's attraction, which means that the rocket has no more to give a vertical force to counter the Earth's attraction. The rocket can keep its orbital speed without having to produce a horizontal force, for in the void there's no resistance force to slow down the rocket. The rocket can naturally follow its orbit without having to use its engine. The change of attitude of the rocket from vertical to horizontal is very slow, progressive and regular. It can in no way be brutal. If the rocket, after its initial vertical ascent, was brutally turned in a horizontal attitude, as it has not gained the horizontal speed allowing to produce a centrifugal force which counters Earth's attraction, it would start to fall back to Earth. As it is falling down, it would gain horizontal speed, but not fast enough to have reached the necessary centrifugal force allowing to counter Earth's attraction before it hits the ground. The crash is inevitable. After the pitch over, we can see the lunar module descend. It does not come from a move of the camera, but simply from the fact that the lunar module no more counters the lunar attraction, as it currently has a horizontal attitude, which means that its engine no more produces a force directed towards the moon. Its fall suddenly stops, which could only be explained that it has taken again a vertical attitude. Then we can see it makes a strange sinusoidal move with a grown amplitude. Some think that it would come from a move of the camera, but it is not possible. From the move the camera was pre-programmed, and if the operator had tried to follow the lunar module, we would not have seen a continuous move like what we see, but a discontinuous one instead, because of the command delay, and moreover, the operator would have tried to move the lunar module near the middle of the image and would not have kept it near its bottom. In fact, this sinusoidal move has an explanation. The first problem of the Ascent stage is that, unlike the descent engine, the Ascent engine was not gimbaled, and thus it could not be swiveled to remake the alignment of the thrust with the centre of mass. The second problem is that, unlike in the descent stage, there is only an oxidizer tank and a fuel tank in the Ascent stage, and consequently the centre of mass was still more shifted in the Ascent than in the descent. Consequently, there was a growing misalignment torque in the Ascent, and this misalignment torque could only be compensated with the lateral thrusters, as these ones could not be throttled. A growing swaying move could not be avoided. The fact that the tank of the oxidizer is placed closer to the Ascent engine is explained by the fact that the oxidizer has a greater density than the one of the fuel, 1.5 times greater. If they were placed at the same distance, the difference of density of the propellants would make the lunar module turn on the side of the oxidizer tank. At the beginning of the ascent, when the tanks are full, their contents are heavier than the containers, so the misalignment torque is limited. But as the tanks are emptying, the difference between the contents and the containers decreases, and consequently the centre of the mass of the lunar module shifts towards the fuel tank, with the consequence that the misalignment torque increases. As the lateral jets of the RCS cannot increase their frequency of correction of the misalignment torque, the consequence is that the amplitude of the oscillation of the lunar module progressively increases. The purpose of this animation is to make understand what happens and not to present the exact reality. Even if this was possible to correct the misalignment torque with the lateral thrusters, it still was uselessly wasting their propellant and complicating the guidance, for they are also used to modify the trajectory of the lunar module, whereas this propellant would have been saved if the Ascent engine had been gimbaled. Clavius himself acknowledges this oscillating behaviour of the lunar module, and he says this on his site. As the off-axis thrust caused the Ascent stage to rotate, the RCS jets fired to counter the rotation and return it to the correct attitude. This is why the films of the LM Ascent seem to show a periodic swaying or oscillation. The RCS fought the off-axis Ascent engine. And if ever the misalignment torque was becoming stronger than the counter torque that the lateral thrusters could provide, the Ascent would fatally end. This is the logical command interface of the lateral thrusters, RCS, which can be found in the handbook of the lunar module. What we see about the vertical thrusters is really surprising. Each command activates two vertical thrusters directly opposed to each other on the same cluster. How can the RCS work when each command of the lateral vertical thrusters activates two vertical thrusters directly opposed to each other on the same cluster, thus cancelling their mutual effects? The document also allows a table of rotational manoeuvres which is less absurd, for the two thrusters activated by each command are not on the same cluster but on diagonally opposed clusters. This table contradicts the schematics we have seen, and even if it seems more coherent than schematics, it still has a big problem, and it would not have allowed to normally control the attitude of the lunar module. Indeed, each command acts both on the pitch and the roll. With this table, it is impossible to pitch without rolling and vice versa. In fact, pitching without rolling or rolling without pitching cannot be done with two thrusters only. 4 thrusters are required to make it. For instance, this schema allows how the lunar module can be pitched up by finding the thrusters A4D, B1D, A3U and BTU, and the roll command also needs 4 thrusters. The interface of command of the vertical thrusters had 3 commands, which could be either positive or negative, so it was in fact making 6 different commands. The pitch, rotation around the y-axis, the roll, rotation around the z-axis, and the vertical translation command, X trans L. And the interface command of the horizontal thrusters had 3 commands, which could be either positive or negative, so it was in fact making 6 different commands. The yaw, rotation around the x-axis, a translation on the right or the left, a translation forward or backward. In order to communicate with the LGC, the AGC was using channels on it which could send information to the LGC, or from which it could get information from it. In order to write into a channel, the AGC had a write instruction. Normally there should have existed a channel with 12 bits to send the commands for controlling the RCS to the LGC. A bit to send a pitch command, a bit to send the sign of the pitch command, a bit to send a roll command, a bit to send the sign of the roll command, a bit to send a command of vertical translation, and a bit to send the sign of this vertical translation, a bit to send a yaw command, a bit to send the sign of this yaw command, a bit to send a translation along the y-axis, and a bit to send the sign of this command, a bit to send a translation along the z-axis, and a bit to send the sign of this command. But in fact, instead of that, there are 2 channels for controlling the RCS, with 8 bits on each of these channels, which means there are 16 commands sent to the LGC for controlling the RCS instead of 12. Instead of sending them normal commands of rotation and translation, 3 commands of rotation, either positive or negative, and 3 commands of translation, either positive or negative, These channels would allow the control of 16 thrusters of the RCS, and what the LGC does not allow. It would make no sense that the AGC would independently control the 16 thrusters of the RCS, for nothing would prevent it from activating thrusters which are incompatible. For instance, by setting the 8 bits of the two channels 5 and 6 to all 1s, it would activate all the 16 thrusters of the RCS, which would mutually cancel their effects. If they all have the same thrust, the result is that the lunar module would not react to these thrusters, while it would uselessly waste the propellant of the RCS. That shows how absurd it would be that the AGC could individually command the thrusters of the RCS without control from the LGC. Moreover, the routine which controls the attitude of the lunar module does not even write into these channels, which means that it does not try to control the lateral thrusters, and these channels could not even be used by the LGC. It simply means that the AGC has no control of the RCS. The LGC could automatically set the engine on or off, what the astronauts could do also manually with the engine start-stop button, the engine on and engine off commands. The AGC had an access to the command engine on and engine off through 2 bits in the channel 11. Writing a 1 in the bit 13 of this channel was allowed to send an engine on command, that is to set the engine on, and writing a 1 in the bit 14 of this channel was allowed to send an engine off command, that is to set the engine off. Now, how was the thrust adjusted? The way that it was adjusted is described in the technical manual under the lunar module. The increased throttle and decreased throttle commands were inputs to a counter. The increased throttle command was allowed to increment the counter, and the decreased throttle command was allowed to decrement the counter. The output of the counter was allowed to control the thrust of the engine when it was the LGC which had the control of the thrust, that is, when the engine control mode was in auto. Sending a pulse on the increased throttle command was allowed to increment the counter, and thus to increase the thrust of the engine. The documentation says that the pulse on increased throttle was increasing the thrust by 2.7 pounds. Sending a pulse on the increased throttle command was allowing to increment the counter, and thus to increase the thrust of the engine. The documentation says that the pulse on increased throttle was increasing the thrust by 2.7 pounds. So increasing the thrust was done by sending trains of pulses on the increased throttle command, while decreasing the thrust was done by sending trains of pulses on the decreased throttle command. The maximum thrust of the main descent engine was 9,900 pounds, and the minimum thrust was 1,280 pounds. So, if each pulse on the increased throttle and the decreased throttle commands was making a variation of 2.7 pounds of the thrust, it means that the thrust could be adjusted by 9,900 minus 1,280 divided by 2.7 equaling 3,192 steps. This could be made with the command of 12 bits. 12 bits represents a value of 4,096. It means there should be an output channel of the AGC on which 12 bits are reserved for the control of the thrust. It would then work this way. When the AGC wants to set a desired level for the thrust, it would write the corresponding level on 12 consecutive bits of a dedicated channel. The LGC would then use this desired thrust to compare it with the current thrust. If the desired thrust is greater than the current thrust, the LGC would send desired thrust minus current thrust pulses on the command increase throttle to increase the counter controlling the thrust by this value. If the desired thrust is smaller than the current thrust, the LGC would send current thrust minus desired thrust pulses on the command decrease throttle to decrease the counter controlling the thrust by this value. This way, the current thrust would be maintained equal to the desired thrust of the AGC. But there was no channel which was allowing the AGC to control the thrust of the main engine. Yet the 12 bits preceding the bits of the engine on, bit 13, and the engine off, bit 14, could perfectly have been used by the AGC to specify the desired level of thrust. Instead of that, these bits are only used for light indicators. The power descent could perfectly be done without these light indicators, but it could not be done if the AGC could not control the thrust of the main engine. The thrust is set at a maximum at the beginning of the powered descent and decreased after the braking phase, and when the lunar module is moving over the lunar surface in order to find a spot to land on, the thrust is continually adjusted to compensate the lunar attraction as the weight of the lunar module decreases. Moreover, there are plenty of spare bits on other channels which could have been used for these light indicators. The program Burn Baby Burn, which is called the start of the power descent, should put the engine at full thrust, but if it effectively sets the engine on by setting the bit 13 of channel 11, it does nothing to change its thrust, which is not surprising since it has no command to do it. So, the AGC has no way to control the thrust of the main engine. There was no way with the control of either the RCS or the thrust of the main engine that was making the power descent completely impossible. And that was also making the power descent impossible for the same reason, and the power descent was still more needed in the RCS than the power descent, for it has to compensate the misalignment torque, what the power descent did not need to do, for unlike the ascent engine, the descent engine was gimbaled and could thus be swiveled to remake the alignment of the line of the thrust with the centre of mass. In fact, the engineers have given many hints that the missions were fake. All the anomaly reports of the missions are nothing but jokes, but the more tasty jokes are what happened in the descent of Apollo 11 and Apollo 14, with the problem of the 1202 alarm for Apollo 11 and the problem of the abort button on Apollo 14, that people consider as simple incidents which could be solved, which are in fact hilarious jokes, as you are going to see. Initially, the radar switch was on the on LGC position, and in this position everything was okay. The AGC was receiving normal radar pulses. But Buzz Aldrin would have put this radar switch on the slew position. The dialogue says that this was because of the erroneous indication of the checklist, but he would have given another explanation, suggesting it would have been on his own initiative. In this position, the mission report says that two dephased signals of high frequency would have created artificial fast pulses which had nothing to do with the real radar input, as the creation of these fast radar pulses was internal and not external. It could have been tested on Earth, and so the engineers could not have ignored it. It could only be intentional. The problem is that unlike all the other computers, the processor of the AGC was counting these pulses with what they call hidden instructions. That is, instructions which run independently of the current program, but which prevent a hidden instruction in the current program from being executed each time that a hidden instruction is executed. Normally, all the other systems, including the one of the Saturn rocket, count hardware pulses with an electronic counter. No other processor has hidden instructions to count hardware pulses. This is pure heresy, for a processor only makes intelligent work, and not work which can easily be made by other specialized devices. And the count of pulses of the electronic counter can be read by the processor with an I/O read operation. And the AGC had an instruction to read from a channel, which means that it could perfectly have read the count of pulses provided by an electronic counter from a channel. If the AGC had worked that way, it would not have been overloaded when the fast radar pulses occurred. It would have just seen that it was reading a too high count of pulses from the channel, and would have issued a comprehensive alarm clearly indicating the problem, instead of an alarm which was not at all informative of the source of the problem, and would not have had to be restarted. Instead of that, because of the fast radar pulses it had to count with hidden instructions, the AGC was taking more time to count these pulses than to do its normal guidance work. Supposing it would have been able to do it, it could have not finished the guidance routine in time, that is, before the next guidance routine was started. The consequence is that there was an accumulation of delayed guidance routines, for a new guidance routine was started each 2 seconds. So there was a moment that the delayed routines had exhausted all the available memory resources, as a guidance routine was allocating memory resources each time it was started, even if it could not immediately run, and when this was happening, the interrupt routine could not find the memory resources it was needing to run, which was generating the 1202 alarm. The bailout procedure was then called, and its job was to remove all the delayed guidance tasks from the waiting list, as they were too late and could never run, and return their allocated memory resources to the pool of memory resources, so that the interrupt routine could allocate the memory resources it was needing, and therefore run. Normally, the AGC could normally run again, restarting from the point it had been interrupted. Instead of that, the AGC was coming back to the last waypoint, reloading the data which had been saved at this point, and executing again the instructions between this waypoint and the point it had been interrupted, which was a totally useless waste of time. Moreover, saving data at each waypoint was representing a considerable waste of time and memory, for it was meaning a sequence of read and write accesses in the magnetic memory, and this is far from being instantaneous. Nowadays the memory accesses are extremely fast, but the memory accesses in the core magnetic memory were rather slow in comparison, and also it means that the data had to be reserved in memory for saving the data of the program, and the AGC had much less erasable memory than fixed memory, and this saving process is nowhere to be found in the program of the AGC, so here we have a total absurdity. And the irony is that the problem of the 1202 alarm could have immediately stopped if the ground had instructed the astronauts to put the radar switch back on LGC. But no, the ground just told the astronauts to ignore the problem and proceed, with the consequence that the 1202 alarm, or 1201 alarm, could happen again. In Apollo 14, at the beginning of the descent of the lunar module on the Moon, the astronauts saw the abort stage button intermittently flicker. An astronaut gently tapped on it, and it went off. The problem would come from a spurious signal in the abort logic interface. The abort stage button is the abort button which allows to drop the descent stage before returning to the command module, while the abort button simply aborts the mission and allows to return to the command module with the descent stage still attached. The abort stage button is ignored before the powered descent, for it is still time to come back to the command module with the descent stage attached. But in the powered descent, the spurious abort signal might command the separation of the two stages of the lunar module without the astronauts having asked for it by pressing the abort stage button. It means that, if no solution is found for this problem, the mission cannot be carried on and has to be immediately aborted. So the ground called the engineers at the MIT and asked them to find a solution for this problem. So the MIT team quickly devised a modification to solve this problem and sent it to Houston. As the astronauts had to change the program, otherwise the spurious signal could cause the abort before the procedure was made, the astronauts had to manually set the throttle command to maximum in order to do what the ignition routine would have normally done if the current program had not been changed. And at the end of the maneuver, the astronauts were instructed to put back the hand control of the thrust control back to minimum, in order to let the guidance take control of the thrust again. But it is completely absurd. This is not what they must do, for the manual control of the thrust and the automatic control by the LGC are not cumulative, but exclusive. It is not one and the other, but one or the other. The thrust is controlled by either the hand controller or the LGC, but not both in the same time. When the hand controller has the control of the thrust, the LGC does not have the control on it at all. Thrust controls switch on manual position. And when the LGC has the control of the thrust, the hand controller has no action whatsoever on it. Thrust control switch on the auto position. So, the astronauts should not set the manual control of the thrust to minimum, but simply change the thrust control switch from manual to auto, in order to give back the control of the thrust to the LGC, in which case the hand controller is not taken into account. But the problem is that the abort stage button will not work in the descent, which means that if it is not possible to land on the moon, with craters everywhere, the lunar module will crash on the moon when the fuel is exhausted, as the return to the command module is impossible. Some think that since it was not possible to make the abort with the AGC, the AGS, the abort guidance system, the secondary computer, simpler than the AGC, could be used for that purpose. But the AGS was only intended to be used in the ascent, not the descent, and the AGS also uses abort stage button for the separation of stages, so it has the same problem with the spurious signal in the abort interface. And also the AGS is not immediately ready for use after the control has been given to it. It needs preparation. Its documentation says that it needs at least 30 minutes of preparation prior to liftoff, which excludes using it for the abort when flying over the lunar surface to find a safe spot to land on. But the best is that the abort stage button was directly an input of the LGC. And the abort stage button was directly triggering the explosive system. The AGC could not prevent it from doing it. In the channels which were allowing the AGC to communicate with the LGC, there was no bit which was allowing the AGC to allow or inhibit the separation of stages. In fact, all the let abort bit was doing was to allow the descent program to be replaced with the ascent program. But if the abort stage button was separating the two stages, and the AGC was remaining in the descent program because resetting the let abort bit was preventing the AGC from switching to the ascent program, it was worse than if the AGC had proceeded to the ascent program, for the ascent program would at least have allowed the lunar module to return to the command module. While if the AGC goes on controlling the descent engine, while in fact this one has separated from the lunar module, sure, the lunar module will make the descent on the moon, but the landing will be a little brutal. And in the schema of the separation of stages which is shown in the technical documentation of the lunar module, we find monostables. They have been coloured pink in this schema. A monostable is a circuit which allows to delay a signal. It means that the explosive bolts and cable shearers are not all triggered at the same time. Some are immediately triggered, others through the monostables. That is, delayed relatively to the first ones. The consequence is that the separation is not going to be homogeneous. Which means that when the separation is commanded, either intentionally or by the spurious signal of the abort interface, the ascent stage is going to wildly spin, like what happened in Apollo 10. The Apollo 13 mission distinguishes itself from the other missions by the fact that because of the accident which happened in the travel to the moon, it could not land on the moon as the lunar module was used to bring back the spaceship to the Earth. In fact, it is not all a failed mission. It would have been if the astronauts could not have been brought back alive, but the fact they have could be shows that it was still more a successful mission than the other ones, for the condition in which the return to Earth was made are incredible. But there are plenty of facts which also cast a serious doubt on this mission. If we don't have photos taken on the lunar surface in this mission, we still have photos taken during the travel to the moon, and they also talk. Indeed, there are two photos of the Earth which are shown in this double view, AS13608597 on the left and AS13608599 on the right. So, what is abnormal with these two photos? Independently, nothing, but in conjunction with each other, they prove the hoax. Indeed, you can see that the direction of the Earth's shadow turns relatively to the direction of the lit parts of the Earth. It is not possible. The shadow cannot turn relative to the Earth. It can turn on a long period because the inclination of the Earth's spin axis relative to the solar plane changes along its orbit around the Sun. But here, the interval between the two photos is a relatively short one, and the shadows cannot turn relatively to the lit part of the Earth. If it turns, well, it proves that these photos cannot have been taken during the travel of Apollo 13 to the Moon. In order to show the problem, the two photos have been superimposed on this animation, adjusting them in size and orientation. The Earth of the second photo is slightly smaller than the one on the first photo, so that the black parts were perfectly superimposed on each other, and here, on this animation, it is very clear that the lit part of the Earth turns relative to the shaded part. In her series Vintage Space, Amy Shearer Tittel, she may look beautiful, but that does not make her an expert, tells us a nice story about a so-called gimbal lock. According to this story, the gyroscopes should avoid approaching a dangerous attitude called gimbal lock, at which they would stop to normally work, which would have resulted in keeping the spaceship out of a critical attitude in Apollo 13. In fact, what Amy does not realise is that there is no such thing as a gimbal lock. This is a joke of the engineers, and God knows there are many in the mission reports. A gyroscope can take any attitude, and it does not directly give an angle, but a variation of angle, which is completely different. In order to be used, a gyroscope needs a reference. That is why the IMU needs to be initialized in order to be usable. And, where we're in a three-dimensional system, 3 stars are normally used for that purpose. When the spaceship is near the Moon, the third star can be replaced with the lunar gravity given the direction of the Moon's center. From a better precision, the stars which are used should be rather far enough from each other. That's why they had better be from different galaxies. In the lunar module, the star alignment system was rather unpractical, for unlike in the command module, it was using a large angular view, and the alignment was made by successively aligning the star with a cross and a spiral, and the alignment with the spiral was not precise at all. After the alignment with the stars is made, their reference angles are associated with the current attitudes of the gyroscopes, which means that these attitudes don't need to be changed. And thereafter, each time there is an attitude of change of the spaceship, send pulses to the AGC, that this one must count in order to update the angles. So we are sorry, Amy, you made us a nice demonstration, but completely false. The gimbal lock was just a fairy tale from the engineers, and they must have laughed well when making it up. In mid-distance between the Earth and the Moon, a serious accident happened in Apollo 13. An explosion occurred, one which seriously damaged the service module, thus jeopardizing the mission. This photo of the service module, taken after it had been jettisoned, shows the importance of the damage. It is absolutely obvious that this explosion had consequences on both the trajectory and the attitude of the spaceship. The trajectory was deviated and the spaceship started spinning, as in the void, unlike in the atmosphere, there is no resistance force to slow down the spin of the spaceship. It will spin as long as the spin is not countered by the lateral jet thrusts. So, logically, the normal trajectory of the spaceship was modified in an unknown way by this explosion, which means there should have been a correction to put the spaceship on the normal trajectory again, and also to stop the spin of the spaceship. Not only there has been no correction, but moreover, the AGC was stopped for 80 hours after the incident. The heaters of the IMU were also stopped, and the story says that the engineers would have been worried that the fact that the gyroscopes were no more heated would make them lose 1/100th of a degree in precision. But, as already said, the IMU does not directly give angles and speeds to the AGC, but pulses which must be counted to update the angles and speeds. The fact that the AGC stopped means that it was not updating the angles and speeds. Meanwhile, it was losing the variations of angles and speeds while it was stopped. Yet, as the spin had not been countered, the angles were constantly changing while the AGC was stopped. It means that, when the AGC was powered on again, it had no idea where it was, and neither was it knowing the current attitudes of the spaceship. That means that it was not just 1/100th of a degree in angle precision that the AGC was losing, but several degrees. Despite that, we must believe that the spaceship of Apollo 13 perfectly kept its trajectory after the incident, and the AGC was able to normally resume its guidance after it was powered on again. And there is also a problem about the way that the spaceship behaves as it is flying over the lunar surface. Instead of flying in a regular way, we see it making a swaying move. Normally, it should not sway, for the engine is gimbal precisely to avoid the swaying move. But it is not exactly a swaying move, it is still more strange. The spaceship alternates sequences in which it moves straight with sequences in which it stops and turns both ways. This animation illustrates what the spaceship does according to what is filmed by the camera. This is simply impossible. The spaceship cannot absolutely behave this way. This is simply impossible. Then we see the lunar artifacts grow, which means that the spaceship is getting closer to the lunar surface. Then we see the lunar artifacts shrink instead, which means that the spaceship is getting away from the lunar surface. Then we see the lunar artifacts grow, which means that the spaceship is getting closer to the lunar surface again. In short, the spaceship would alternatively come closer to the lunar surface and get away from it. But why would the spaceship do this absurd maneuver? The spaceship is damaged and in a precarious state. The only concern of the astronauts and the ground is to take back the astronauts to the Earth in as safe way as possible, and it excludes making any unnecessary complicated maneuvers. It is absolutely obvious that the only reasonable maneuver was to make the spaceship follow a normal regular orbit around the Moon in order to catch the return trajectory to the Earth. The Apollo believers think they have found the ultimate parade against the Moon hoax, which is what they call the third-party evidence. But this third-party evidence is not as good as they think and can easily be destroyed. One strong piece of evidence is that the Apollo believers think that they have is that the astronauts have brought back rocks from the Moon, and these rocks have peculiarities which cannot be found in the rocks on Earth. 2 years before the first Moon mission, Von Braun made a trip to Antarctica, so to collect lunar meteorites that could pass for lunar rocks. Indeed, meteorites fallen into Antarctica and found in the 80s show the same composition as the lunar rocks that would have been brought back by the astronauts. These meteorites could then be split into a certain number of lunar rocks that could be claimed to have been picked up on the Moon by the astronauts. The Apollo believers, aware of this argument, replied that the lunar rocks show little holes called zap pits, and which would have been made by colliding micrometeorites, which would not be the case with rocks produced by the previously described method. In fact, it is NASA itself which answered this argument by showing a rock. It claims to be Martian, on which Curiosity's lasers would have pierced the small holes. This double view shows the rocks before the holes are pierced and the rock after. So the answer to the presence of the zap pits is the laser which is able to produce them. The Apollo believers still try a trick by saying that Curiosity's lasers is a modern laser, and that nothing proves that the lasers were able to produce such a feat in Apollo's time. But the lasers of the 60s were able to do it. They were able to drill very thin holes into diamonds and even cut titanium, which is the hardest known metal, so piercing little holes in rock was certainly no problem for them. Moreover, the holes we see in the so-called lunar samples seem to strangely always have the same size, like the micrometeorites striking them all had the same standard size. Whereas it is more probable that if micrometeorites were striking a rock on the Moon, these micrometeorites would have different sizes and we would consequently have seen different sized holes, like on this photo composition, on which holes of various sizes have been added. Moreover, only the rocks which are analysed need to be authentic, It was possible for NASA to add fate rocks to the stock of lunar rocks which would have been brought back by the astronauts, so to increase their volume, provided that it would make sure that the latter would never be analysed, like this lunar rock of the Dutch Museum, of which NASA was probably not figuring that the experts would someday have the idea of analysing it to finally realise that it was vulgar petrified wood. There is even better. Recently, Australian geologists have found, in an Australian area rich in minerals, a mineral which has the same structure as the rocks which would have been brought back by the astronauts. This means that it is possible to find directly on Earth lunar rocks. How much time has NASA been aware of the existence of this mineral on Earth? This probably allowed it to increase its stock of real lunar rocks and to give more ones to be analysed by independent laboratories. One other strong point of the Apollo believers is that the Apollo astronauts would have put on the moon retroreflectors which are able to send back a laser beam. Many people are not aware that it was already working before the moon missions. In an article, The Laser's Bright Magic, published in the National Geographic magazine by Thomas Mello, the author relates an experiment which proves that a laser beam can bounce on the moon and successfully return to the Earth. 4 years ago, a ruby laser considerably smaller than those now available shot a series of pulses at the moon, 240,000 miles away. The beams illuminated a spot less than 2 miles in diameter and were reflected back to Earth with enough strength to be measured by ultra-sensitive electronic equipment. So, as soon as 1962, it was already possible to bounce a laser beam on the moon, much before the moon missions, without a retroreflector being necessary for that purpose. Besides, the moon is so reflective that its reflectivity is used by radio telescopes to obtain the lunar relief. The principle is that the radio telescope sends ultra-short waves to the moon and measures the time that these waves take to come back from the moon. It then sweeps the moon with its signal to obtain the return differences of the signal, so the relief of the studied area. For instance, a radio telescope sweeping the moon allowed to obtain the relief of a pole of the moon as shown in this figure. The radio telescope measures the relief but does not allow to obtain the shadows, which have been artificially added to make the photo more realistic. And in order to obtain this result, it has not been necessary to put a retroreflector everywhere. If the lunar ground was not reflective, it would not work. And the laser beam arrives diffracted on the moon, and it strikes it on a quite large surface. Even if there is a retroreflector, which is in the area which is struck by the laser beam, it only receives an extremely small part of the signal, and it cannot send back more than what it receives. On the graph of the received photons, the concentrated bar represents a variation of distance of 45 centimeters. If this bar was coming from a retroreflector, and that this retroreflector was correctly orientated toward the Earth, this bar should be narrower. This is a graph showing the measures of the laser at the two different stations. They are strange that these differences and variations while the prisms of the retroreflector are supposed to send back the laser beam exactly in the direction it came from, and with an extreme precision. Notice that even if averagely this graph shows again that the moon tends to slowly move away, sometimes the moon comes nearer again, and not necessarily for the same station. It may come nearer to a station while it moves away from the other one, and vice versa. While it is obvious that the moon is continuously moving away, it is not playing yo-yo. In fact, the broadness of the concentrated bar of return photons entirely depends on the inclination of the average lunar surface relativity to the laser beam and also its relief. The Apollo landing sites have not been randomly chosen, at least the ones on which a retroreflector has been put. They have been chosen after a laser ranging test has shown which were the best locations of the moon which were allowed to obtain the most concentrated bars of return photons. It is obvious that before the moon missions, NASA has swept the surface of the moon with a laser in order to find the best spots, returning the best signal with a concentrated bar of photons. It has apparently found only 3 of them, otherwise it could have put a retroreflector on all the landing sites. And on the photos of the missions, it is obvious that the astronauts have made a rather lousy job when orientating the retroreflector towards the Earth. In the mission report of Apollo 15 we find these statements at page 26. The McDonald Observatory team initially acquired a return signal from the Apollo 15 instrument August 3, 1971, when atmospheric conditions first permitted ranging, and no degradation of the retroreflector appears to have resulted from Lunar Module Ascent engine firing. So what's the problem with these two statements? The problem is that the astronauts left the Moon on August 2nd, so before the first ranging test was performed on Apollo 15. In this circumstance, how can they assert that there was no degradation of the retroreflector before the liftoff of the Ascent engine, and after, since they have nothing to compare the test made after the liftoff with? And on the retroreflector of Apollo 15, we can see a shadow which comes over it. This shadow is the one of an astronaut which stands on the left of the photo. The sun was coming from east and the shadows were consequently orientated towards west. So, if the shadow is orientated towards the right of the photo, it means that the retroreflector is currently orientated towards the north of the Moon. But, as the side of Apollo 15 was on the north of the Moon, and at almost null longitude, it is towards the south that the retroreflector had to be orientated to point towards the Earth. On the next photo, the retroreflector seems correctly orientated, for its shadow is on its right. It is seen the other way than on the previous photo. However, when we look closer, we can see that the solar compass is not correctly adjusted. The retroreflector should be turned counterclockwise for the solar compass to be correctly adjusted. And why the Russian retroreflector of Lunar Cod 2 would work less well than the ones of the Americans if the corner cubes are allowed to send back the signal in whatever direction it came from. What is particularly tasty is that recently they would have found the Rover of Lunar Cod 1 while it has been lost for more than 4 decades. It is rather strange that the Russians would not have known in what direction it had been heading in, and they would have let it wander erratically without control. But what is really surprising is that the retroreflector of Lunar Cod 1 would work almost 3 times better than one of Lunar Cod 2. While it is the same retroreflector, we can bet that in the future, if they find another place on the Moon which gives an excellent signal, they will move Lunar Cod 2 to that location so that they can say that it is the retroreflector of Lunar Cod 2 which sends back this new signal. One third independent piece of evidence would be the photos taken by a satellite orbiting the Moon, the Lunar Reconnaissance Orbiter, which supposedly show the remains of Apollo on the Moon, the descent stage, the Ascent, the Lunar Rover. They would even show the rover tracks and the footsteps of the astronauts. But what credibility do these photos have? The photo on the left of this double view is extracted from a video of Apollo 15 after the ascending stage of the lunar module has left the Moon. The photo on the right is a close-up of the supposed remaining part of the lunar module on an LRO picture. The white we see comes from an arrow pointing at the LEM. The shadow we see on the LRO picture doesn't correspond at all with the shape of the lander. Moreover, the shadow of the lander should not be so much longer than wide, except if the sun is extremely low, raising the ground. But in that case, the holes we see on the LRO picture would not be particularly lit. They would appear completely blackened. And all the photos of the LRO show a completely abnormal shape for the lander. For instance, on this photo, Challenger, the lander of Apollo 17, is completely irregular, and the footpads, the white spots we see around the lander, are disposed asymmetrically around the lander. But the best proof that the photos of the LRO are fake is that the distances between the artifacts of Apollo are inconsistent and change in an abnormal way. For instance, on this LRO photo of the landing site of Apollo 15, the legend says that a pixel of this photo represents 52 centimeters. This photo is 540 by 540 pixels. If we measure the distance between the lunar module and the Ascent, it gives a distance of 71 meters. On this photo of the landing site of Apollo 15, there is a reference to show a distance of 50 meters. If we use this reference to measure the distance between the lander and the aslet, we find a distance of 90 meters, so quite different this time. And the official distance between the lander and the aslet is 110 meters, and it is confirmed by the calculation with the lunar coordinates. So we have three different distances, so either the photos of the LRO are fake, or the artifacts of Apollo magically move on the moon. Some have also said that the LRO photos could have been taken with an angle instead of being taken in perpendicular, in which case it could cause a dilation of distances. This argument can easily be discarded by showing that the altitude at which the photos are taken is much greater than the width of the landing sites, which makes that the landing sites are in fact seen under a very small angle, which means that the dilation of the pixel from an edge of the photo to the other one is not even 1%, supposing that the photo would not be vertically taken. This is an LRO photo of the landing site of Apollo 17. The indicated scale can be used to measure the distance between the lunar module and the aslet, and also the distance between the lunar module and the lunar rover. Using this scale, we find a distance of 208 meters between the lunar module and the aslet, and a distance of 146 meters between the lunar module and the lunar rover. But the official distance between the lunar module and the aslet is 190 meters. This distance is mentioned in the dialogue of Apollo 17 at time 118 hours, 56 minutes and 3 seconds. The lunar coordinates of the lunar module and the aslet are indicated in the official table of lunar coordinates of the Apollo missions. The lunar coordinates of the lunar module of Apollo 17 were latitude 20.18809 north and longitude of 30.77457 east, and the lunar coordinates of the aslet were latitude 20.18935 north and longitude 30.76796 east. If we input these coordinates into the lunar distance calculator, we find a distance of 197 meters between the lunar module and the aslet, according to these lunar coordinates. So we have three distances between the lunar module and the aslet: 190 meters for the official distance, 197 meters for the distance calculated from the lunar coordinates, and 208 meters for the distance measured on the LRO photo, and they are all different from each other. Still better, if we measure the distance between the lunar module and the lunar rover, still using the indicated scale, we find a distance of 146 meters, but the official distance between the lunar module and the lunar rover was 158 meters. And if we use the official distance between the lunar module and the lunar rover instead of the indicated scale as a reference, then we find a distance of 225 meters between the lunar module and the aslet, still more different from the official distance and the distance calculated from the lunar coordinates. NASA has produced a table of lunar coordinates of the items of Apollo in 1987. NASA has recently updated this table. If the coordinates of Apollo 17 are the same for the two tables, the coordinates of Apollo 15 are quite different, enough to obtain quite different distances between the lunar module and the aslet. Would the lander and the aslet of Apollo 15 have moved between these 2 days? And what is surprising is that all the photos of the LRO contain the signature of Adobe Photoshop in their header, not only those which bear indications, and NASA was not needing Photoshop to add these indications, it had its own tool to do it, but also those which bear no indications. But why would NASA need Photoshop to process the photos of the LRO? This photo has also been processed with Photoshop. It bears the signature of Photoshop. Yet, it could easily have been improved with Photoshop to remove these bars which come across the photo. So why use Photoshop on this photo if it is not to try and improve it? This is an LRO photo of the crash of the Ascent stage of Apollo 12, which has been deorbited after its return to the command module in order to crash on the moon. And this crash, measured by the seismometer of the aslet, the Ascent stage is practically out of propellant when it crashes on the Moon, for its last reserve propellant has been used to make the deorbit maneuver. This crash looks the same as one of the SIVBs which have been sent to the Moon to crash onto it. But if the SIVBs effectively strike the Moon vertically, it is very different with the Ascent stages deorbited to crash on the Moon. The deorbit maneuver, which is made after the lunar module leaves the command module, consists of decreasing enough the orbital speed so that the corresponding trajectory will not avoid the lunar surface and will make the lunar module crash on it. The direction of the impact is mostly horizontal, for the remaining propellants only allow a limited decrease of speed. For the impact to be vertical, the speed of the lunar module would have had to be null, but the remaining propellants were not allowing it. And it is besides confirmed in the mission report of Apollo 12, which says the angle between the impact trajectory and the mean lunar surface was 3.7 degrees at the point of impact. 3.7 degrees is very close to horizontal. So seriously, if the lunar module had arrived almost horizontally on the Moon, how could it have caused this type of crater, which can have only resulted from a vertical impact? It should have rather raked the surface of the Moon and left a long trail instead. This is the graph of the crash of the Ascent stage of Apollo 12, recorded by the seismometer of the Ascent. The two upper plots show the vibrations along the horizontal axis, while the bottom plot shows the vertical vibration of the crash. But how can the vertical plot have a greater amplitude than the ones of the horizontal plots when the Ascent stage has arrived almost horizontally on the Moon, with an angle of only 3.7 relatively to the mean lunar surface according to the mission report of Apollo 12? The vertical plot should have shown a much smaller amplitude and should rather have looked like this on the modified graph. Last piece of evidence. If the American moon landings had been fake, the Russians, who were considered fierce enemies of the Americans, would have exposed them. It is the same argument the Russians have used to confirm the validity of the flight of Gagarin, since the American government had validated it. But what were the American media thinking about this flight? Were they agreeing with their president? Absolutely not, and we can cite two precise examples, and they probably are not the only ones. An article published in the Palm Beach Post on April the 19th, 1961, of which here is a scan, and an article published in Lewiston Evening Journal on May the 12th, 1961, of which here is a scan. So, what were these articles saying to contest the exploit of Gagarin? First, they were saying that Gagarin announced he was flying over South America, whereas he had not still covered the third of the distance separating his departure point from South America. Indeed, he made this announcement less than a quarter of an hour after he departed, while he was needing at least 3/4 of an hour to reach it. This is what his successors needed. Then, whereas he still was at an altitude of 200 miles, he announced he could clearly see the fields and collective farms, kolkhozes. To give you an idea of what means an altitude of 200 miles, here is a view extracted from Google Earth at an altitude of 200 miles. On it you can see several departments of France. How could one distinguish things as minute as fields and farms? And there is also this strange contradiction of Gagarin saying he had a nice view of the Earth through the porthole, whereas the Russian chief of the space program said in a conference in Italy that his spaceship had no porthole. And Gagarin did not return in his space cabin, but parachuted out instead, while his space capsule crashed on the ground and was destroyed. So Gagarin could have probably been dropped from a plane instead of jumping from his capsule. At the speed that his capsule was going, Gagarin would have probably been killed had he tried to return this way. So the unanimous conclusion of the American media was that the Russians had cheated, and they were outlining the fact that this was customary from their part. So, why the American government would have accepted to validate this flight, when 3 weeks later the Americans have sent a man to space, Alan Shepard, and unlike Gagarin, he has returned in his capsule and not via a parachute. Kennedy could certainly not ignore the many anomalies of the Russian flight, he must have been informed the same day by NASA. So why would he have accepted to validate this flight and congratulate the Russians for their great exploit? A free gift? Certainly not. No gift is free between two nations. There is always a counterpart. And when Kennedy made 6 weeks later his famous speech to the Congress about sending a man to the moon and returning safely before the end of the decade, he was seeming very confident. It is then not difficult to guess what kind of service he was expecting back from the Russians. It is obvious that he was expecting the American moon landings to happen before the end of his second mandate, with the benediction of the Russians. And far from feeling inferior to the Americans for their manned moon landings, it was in fact the converse. The Russians were saying to their people that it was more difficult to make unmanned landings on the moon than manned ones, because the control had to be entirely automatic and not controlled by man, and thus was requiring a superior technology. Moreover, by making unmanned landings, the Russians didn't have to produce photos of the lunar surface made by the astronauts, and they knew that these fake photos would be contested by people who could see anomalies in them, and it is exactly what happened. Another point of evidence which is shown by the Apollo believers is that the communications of the astronauts would have been caught by radio amateurs. Larry Basinger is a ham radio operator who has become a hero by catching the transmissions of the astronauts talking on the moon. He caught the VHF communications of the astronauts on the moon, but according to his testimony, he did not attempt to pick up the encoded S-band signals from the main Moon-Earth communication link. And that's the whole problem. Only the UHF communications can reach the Earth. The VHF communications are only used for the communications between the command module and the lunar module, and don't reach the Earth. So in other words, Larry Basinger's caught the VHF transmissions which could not reach Earth's surface, while he did not catch the UHF transmissions which are the only ones he could have caught. Very logical indeed. The Apollo believers also point out that the lunar module was followed by tracking stations on the Earth. One of these tracking stations is Jodrell Bank in England. As this radio telescope is located in England and not in US, this radio telescope is considered as an independent source, proving that Apollo was real. However, the radio telescope equipment of Jodrell Bank has been provided by NASA and was controlled by NASA engineers. So, there is better than an independent source. The radio telescope was using the Doppler effect to follow the lunar module. The Doppler effect is what you can experiment when a horning car is passing along. As it moves away from you, the tone of the horn changes and becomes lower. This is due to the change of the shape of the sound wave. This effect is called Doppler effect and is used by the police to measure the speed of cars. The Doppler gives the speed but not the position, which means that this speed has to be integrated to obtain a position, and this position is a relative position, which means that it needs a reference to become absolute. The first half of the graph corresponds to the adjustment of the radio telescope receiver, and only the second half of the graph is significant and corresponds to the actual moves of the lunar module. In fact, at the location that the landing site of Apollo was, it is the altitude of the lunar module that Jodrell's radio telescope was tracking. It could not follow the lateral moves of the lunar module. So, this is in fact the significant part of the graph, showing a steep descent. On the significant part of the graph, we see some little perturbations followed with a straight line. These perturbations would correspond to reactions of Armstrong whilst he was flying over the lunar surface, looking for a place to land on, taking altitude to avoid local obstacles, and the straight line which follows corresponds, according to the explanation which is given under the graph, to the relative velocity between the telescope and the landing point of the Eagle. And this last part is very interesting because it gives a reference which is absent on the graph. There is no known data on the speed of the moon relatively to the Jodrell Bank at the time of the descent of Apollo 11. The moon was then coming closer to the Earth, but Jodrell Bank was getting away from the moon because of the rotation of the Earth, and it was getting away much faster than the moon was coming closer to the Earth. In fact, it is possible to calculate the speed of the moon relatively to Jodrell Bank, knowing the time of the descent of Apollo 11 and the rotation speed of the Earth by building a mathematical model, and this calculation gives a speed which was over 500 kilometers per hour. So, now that we have an idea of the speed of which represented by the straight line which appears after Eagle has landed, we can deduce at what speed the maneuvers have been made by comparing the slopes, and the conclusion is that these maneuvers would have been made at speeds which were much more than supersonic, and the lunar module would have descended too fast, which removes any credibility from this graph. And if the last two bumps could eventually have corresponded with maneuvers to avoid lunar obstacles, concerning the first bump, the lunar module still was too high to be bothered by a lunar obstacle, and the lunar module was then under the control of the AGC, and the AGC would have never made such an unnecessary illogical maneuver. And concerning the last two bumps, we never see the lunar module make such maneuvers on the video of the descent. So this graph is an obvious joke from the engineers, and intended to make us understand that it does not show a descent which in fact never happened. About the stars which do not appear on the photos of Apollo. The Apollo believers explained to us that it was coming from the high luminosity of the lunar ground, which was meaning that a short exposure time had to be used for the photos on the lunar surface, and they give us the example of a photo of a stadium during the night, on which we can see no stars. This explanation stands, but if the astronauts had raised their cameras, then they would not have had the lunar ground in their field of view, and then they could have caught stars. They have never done it on the photos of the missions, but if we see no stars, we can see other items, like the Earth and the Sun. The Hasselblad camera used on the lunar surface theoretically had a 60mm lens, and was using a 70mm film, which gives an angle view of 60 degrees. There is a formula to calculate the angle of the view from the focal length and the film's height. With this angle of view, the Earth would theoretically have the good size on the photos of Apollo if it was seen under its theoretical angle of view from the Moon, around 2 degrees. But in fact, distant objects are not necessarily seen under their theoretical angle of view. If you take the Eiffel Tower from a distant point of Paris from which it is visible, you can see that it will be slightly greater on the photo, taken with a known angle of view, than it should be according to its theoretical angle of view from the point it is taken. And the Moon appears to us bigger than it should be according to its theoretical angle of view from the Earth. So, the idea is to take a photo of the Moon with a camera of known angle of view, which can be calculated from its focal length and the film's height, and to magnify it by the difference of size between the Earth and the Moon, 3.67, to have an idea of what the Earth would look like if taken from the Moon with the same camera. This is a photo of the Moon taken with a camera with an angle of a view of 52 degrees. The little point on the right of this Moon represents the Moon as it would look like if it was seen under its theoretical angle of view. So, our Moon is magnified by the difference of size between the Earth and the Moon, and we replace it with the Earth. It gives this. This is how the Earth would look like if taken from the Moon with this camera. The little Earth on the right represents the Earth as it would look like if it was seen under its theoretical angle of view if taken with this camera. So, now that we have a valid reference, we can see that the size of the Earth would have on the photos of the missions if effectively taken with a 60mm Biogon lens. If we take the photo AS17-134-20384 of Apollo 17 for instance, instead of appearing with the size of the actual photo, left on the double view, the Earth would appear with the size which is represented on the right of the double view. But have the photos really been taken with an angled view of 60 degrees? NASA has built a panoramic with photos made by an astronaut as he turned on himself to sweep the whole lunar landscape. It is really a neat work, and the result cannot be contested, as it has been made by NASA itself. This panoramic covers a whole angle of 360 degrees. The part which is between the two red bars which have been drawn represents a sixth of the panoramic, so an angle of 60 degrees. Now if we compare the photo AS17-134-20425, left part of the double view, with the part extracted from the panoramic which represents an angle of 60 degrees, right part of the double view, it is very clear that the photo AS17-134-20425 covers an angle consistently smaller than the part extracted from the panoramic, certainly not much more than an angle of 40 degrees. And with the real angle of view of the camera, the Earth we see on the photos of Apollo would appear still bigger relatively to the one we see on the photos, something like this. Now, you don't even have to trust the photos of the Moon, though you can make yourself the same test. It is possible to demonstrate that the size of the Earth is abnormal, incoherent, without taking the size of the Moon as seen from the Earth as a reference, simply by comparing the size of the Earth on photos of different missions. Let's consider the Earth of a photo of Apollo 17, the famous photo of Schmidt holding a flag taken by Cernan, kneeling, AS17-134-20384, and the one of Apollo 11, taken by an astronaut raising his camera to the sky, AS11-40-5923, using the high-resolution photos. Here you can see windows containing the Earth of exactly the same size taken from high-definition photos, 200 by 200 pixels. The Earth should logically have the same size on the two photos, and yet you can see that it is not the case. The Earth of Apollo 17 is slightly bigger than the one of Apollo 11. There is a ratio of 1.12 between the two. So, for an equal distance of the Earth of Apollo 17 is 1.12 times bigger than the one of Apollo 11. Of course, there is a question of difference of the distance of the Earth between Apollo 17 and Apollo 11, but even the maximal ratio of distance of the Moon, perigee and apogee, does not explain this difference, for this ratio is only 1.123. Of course, if the Earth of Apollo 17 had been taken as the Moon was at its perigee, while the Earth of Apollo 11 had been taken as the Moon was at its apogee, it could explain this difference of size. But it is far from being the case, as you are going to see. The landing of Apollo 11 happened on July the 20th, 1969. The previous apogee happened on July the 13th, so 7 days before, and the next perigee happened on July the 28th, so 8 days later. The landing of Apollo 17 happened on December the 11th, 1972. The previous apogee happened on December the 4th, so also 7 days before. And the next perigee happened on December the 19th, so also 8 days later. So it means the landings of Apollo 11 and Apollo 17 happened in exactly the same conditions relatively to the apogee and the perigee. And so the distances of the Earth are comparable in these two missions, and the difference of distance much less than the difference between the apogee and the perigee, which means that there is no rational explanation for the difference of size of the Earth between Apollo 17 and Apollo 11. The conclusion is that there is definitely a problem of abnormal variation of the size of the Earth in the photos of Apollo. The size is not the only problem of the Earth of the photos of Apollo. There is also a problem of the orientation of the crescent of the Earth, as you are going to see. The moon landings of Apollo happened near the first quarter of the moon. At that moment, when someone would have been on the center of the visible side of the moon, he would have seen the crescent of the Earth as represented on this illustration, that is, vertical. When an observer is on the extreme east of the visible side of the moon, he would have an orientation which is perpendicular to the one he has when he is at the center of the moon. So, we are going to turn the whole scene so that the observer becomes vertical. And when he appears vertical, this is the way he sees the crescent of the Earth, that is horizontal, with the lit part above. Besides, you'll notice that this is precisely the way that the crescent of the Earth appears when the Earth starts to appear in a photo of Apollo 11, taken with the 250mm lens, as the command module reaches the extreme east of the visible side of the Moon. When an observer is midway between the centre of the Moon and the extreme east of the Moon, he appears bent at 45 degrees on the left, relatively to the one he has when he's on the centre of the Moon. So, we are going to turn the whole scene so the observer becomes vertical. And when he appears vertical, this is the way he sees the crescent of the Earth turned at 45 degrees counterclockwise relatively to the horizontal position. It means that the way that the crescent of the Earth appears orientated on a landing depends on its location on the visible side of the Moon. And the way that the crescent of the Earth appears on the photos of Apollo 17 and Apollo 11 does not correspond with the location of these sites on the Moon. On these photos, the crescent of the Earth has an orientation which is close to the horizontal, while it should be closer to the vertical. It is completely wrong. We can see the Sun on the panoramic, but we cannot see the Earth, for it was too high in the sky, and it is not present on the photo which has been used for the panoramic. But we can see it on a photo, and we know that it was over the left of the South Massive. So, it has been added on the panoramic of Apollo 17. The distance between the Earth and the Sun on the panoramic corresponds to a third of the total length of the panoramic. We know that the panoramic corresponds to an angle of 360 degrees. So a third of the panoramic corresponds to an angle of 120 degrees. But at the same time that the landing of Apollo 17 happened, the angle between the Sun and the Earth was making an angle of hardly more than 90 degrees. And all along the mission, it is going to decrease. It is never close to 120 degrees. It does not stop here. Because the Moon always shows the same face to the Earth moves very little in the Moon's sky. It moves a little because of the Moon's libration, but not importantly. On this photo, AS17-134-20387, the astronauts see the Earth over the left of the South Massive. If, at a given moment, they see the Earth over the left of the South Massive, they should always see it over the left of the South Massive throughout the whole mission. Yet, on this photo, AS17-134-20461, the astronauts now see the Earth over the right of the South Massive. Indeed, we can see the descending slope of South Massive. It means the Earth abnormally importantly moved in the mission. That might explain why it is too distant from the Sun if it keeps moving right. On photos AS17-134-20464 right, relatively to AS17-134-20463, the photographer turns his camera up. Consequently, the lunar module moves down on the photo, and the Earth should follow the lunar module. But in fact, the Earth does not completely follow the lunar module. It moves up relatively to the lunar module. Yet we don't see how the photographer could manage that. For if he can move laterally, he can't move up, elevate himself in the air, and remain at the same distance from the lunar module, which has the same size on the two photos. On this double view, the photo AS17-134-20464 on the right has been corrected to put back the Earth at the position it should have had to be compatible with the photo of AS17-134-20463. That is, the Earth keep moving the same vertical position relatively to the lunar module. Now, if we cannot see any stars on the photo of Apollo, there is still one we can see, our Sun. The problem is the way that it appears is completely abnormal. This is a photo of the Sun taken in space on a close Earth orbit. On it we can see an imprecise contour of the Sun and very clear spokes. And this photo has been taken in Apollo 11 near the Earth, AS11-36-5293. We can see very clearly the spokes of the Sun. Now, This is a photo taken on the so-called moon of Apollo in Apollo 17, AS-17-134-20411. A very strange sun indeed, a neat contour and no spokes. And this photo has also been taken on the so-called moon of Apollo in Apollo 12, AS-12-46-6767. Again, a neat contour and no spokes. Also notice the size of this sun. Whoever thinks that this is the same sun has a serious problem with reality. It is very obvious that the sun that we can see on the photos of Apollo is not the real sun, but a big spotlight instead. Suspended spotlights were also used. And how to explain this photo of Apollo 11, AS-11-40-5935, if there are not two sources of light? There is evidence that the sun moves in Apollo 17. The reflection of the sun on the visor of the astronaut should always have the same size and be at the same vertical position if he holds his head the same. The vertical position of the sun's reflection on a half-spherical surface depends on the inclination of the sun, and it's very unlikely that the sun's inclination would change in a short series of photos. On the photos AS-17-134-20385 left and AS-17-134-20475 right, the astronaut holds his head the same, but the reflection of the sun is bigger and higher on the second photo than on the first one, given the evidence that the sun has been moved between the two photos. It is closer on the second photo than on the first one. This is a photo of an astronaut taken in space in the close orbit of Earth. The reflection of the sun on the visor of the astronauts should always have this size. And now you're going to see another evidence that the sun moves on the photos of Apollo, and it is quite shrewd. On the photo AS-15-82-11057, we can see two luminous reflections, lens flares. A small bright one close to the top of the photo, and a lighter and bigger one underneath. And with these two reflections, we can now obtain the direction of the sunlight by drawing a line going through the centres of these reflections. This photo has a sister, the photo AS-15-82-11056. The photographer just turned his camera on the left to take this photo. This is visible by the identical foreground. Like on the other photo, the direction of the sunlight is obtained by drawing a line joining the centres of the reflections. In order to study these reflections, the best is to make a panoramic with the two photos. The centre of the sun is at the intersection of the two lines of reflections, and that's the problem. This intersection is much above the upper edge of the photo when the sun should normally be just above this edge. It would put the sun too far from the small brilliant reflections, more than the height of the photo. The only possible conclusion is that the spotlight which lights the scene has been moved between the two photos. The case you have seen is not isolated, it is repeated along the missions. Here in the photo AS-16-108-17729, we can see two lens flares. We can deduce the direction of the sun by drawing a line which passes across these two lens flares. And on its sister AS-16-108-17730, we also can see two lens flares, and we can also deduce the direction of the sun by drawing a line which passes across these two lens flares. Now, if we make a panoramic with the photo AS-16-108-17729 and AS-16-108-17730, and we draw the lines which join the lens flares, these two lines should meet at the centre of the sun, just above the upper edge of the photo. But we can see that it is not all the case. These two lines meet much too high, far above the upper edge of the photo. The only possible conclusion is that the spotlight lighting the scene has been moved between these two photos. On the photos AS17-145-22160, AS17-145-22161 and AS17-145-22162, the astronaut is sweeping a landscape by turning his camera. This is a panoramic reconstituted with these three photos. On each photo we find two small sun reflections, lens flares, indicating the direction of the sunlight. The sun is normally just above the upper edge of the photo and aligned with these reflections. Normally the centre of the sun would be on the intersection of the lines of reflections, but we have put the sun way too far from these reflections when it should normally be near them. Furthermore, these lines don't even meet on a common point. In fact, each of the lines of reflections indicates a different position of the light source which is supposed to replace the sun. These positions have been numbered 1 to 3. Between the photos, the sun has been moved. Now, you're going to have to say, the rails on which the spotlights are suspended would have to cover a sufficient area including the whole moon set. It was the case, they had that structure which was allowed to cover a whole moon set. Was the moon set not too vast to be covered by this structure? No, because the moon set was not that vast. When you look at the background, it is always short, it never gives an impression of depth. In fact, they were using models for the hills, like Percy has shown, except that these models were more elaborated than what he shows. We even have photos of these models at the beginning of the mission of Apollo 15. The spotlights were suspended from rails. They could move horizontally in both directions, along the arrow which are drawn in yellow, and also the perpendicular direction for the spotlight could go from a rail to a perpendicular rail at the point they were crossing. The spotlights could also move up and down vertically along the arrow which are drawn in red. Finally, the spotlights could also pivot around two other axes in the directions which are represented in blue and green, so they could be orientated in any direction. Of course, the rails and the spotlights were much bigger than what is shown on this picture. And it is not true that multiple sources of light create multiple shadows. If you have the experience of walking along a line of street lamps, as you walk along this line, you only see one shadow, the one created by the lamp which is closest to you. You are going to say, yes, but when you're at two equal distances from two consecutive lamps, then you should see two shadows. Hardly, for when you're at an equal distance from two lamps, the lamps erase each other's shadows and you will only see very faint shadows. But you will never see two very distinct shadows. So, it is not excluded that they use several spotlights in order to have a better lighting of the whole scene. If you look well on the photos of Apollo, you can see spots in which the shadows are quite faint. And even better, on the photo AS11-40-5950 of Apollo 11, we can see spotlights hanging from the ceiling in the reflection of the solar panels. On all the photos of Apollo, we can see a clear discontinuity between the foreground and the background, a change of texture and colour. To make his film 2001: A Space Odyssey, Kubrick used a special technique, the front screen projection. The front screen projection is a cinematic device which allows scene to be projected behind the actors so the actors appear to be moving on these scenes. A projector which projects the background scenes is placed at 90 degrees relatively to the camera. A semi-transparent mirror placed in oblique at the intersection of the axis of the camera and the projector allows to redirect the scenes on the way of the camera. Behind the real set of the actors there is a special screen called Scotchlight screen, which is extremely reflective and allows to render the redirected projection in excellent conditions. This special screen is made of hundreds of thousands of tiny glass beads, each about 0.4 millimeters wide. These beads are extremely reflective and give the Scotchlight screen a very high power of reflection. It has been invented by the 3M company. In order to create his desert backgrounds for his scenes with the AIDS, Kubrick sent a photographic team to Spain to shoot 8x10 Ektachrome slides. These slides were then projected via the front screen projection system onto the Scotchlight screen. The actors in ape costumes stood in front of the screen, acting out the script. On all the scenes of his movie, we can see a clear change between the foreground and the background, which was not really behind the actors, but projected on the Scotchlight screen behind the actors. The same technique was used to create the fake backgrounds behind the actors who were impersonating the astronauts. In fact, the moon set was not that vast. The fake background which was projected behind the moon set was making it look much greater than it really was. And if the photos are taken on the moon, then why on two photos of Apollo 15, which are taken from very different points of view, the Mounts Hadley we see in the background appear on the bottom of the map? It is possible to superimpose the mountains in the background by turning one photo relatively to the other one, so that their reliefs perfectly match with each other, while, given the difference of distances and angles that the photos are taken from it, it should not be possible. This is the real anomaly, and not the fact that the lunar module had disappeared between the two photos. The front screen projection was also used for the scenes with the rover. A moving landscape was projected behind the rover. This way, it was possible to make believe that the rover was riding a great distance, while in fact it was remaining immobile. So in this sequence, the rover has been disposed as shown, while a film showing a moving background was projected on the Scotchlight screen, giving the impression that the rover was moving, whereas it was still in fact, and it was only the background behind which was moving. This technique is often used in movies to make believe that the car the actors are in is moving, whereas it is still in fact. The camera filming the scene was a little shaken to reinforce the impression that Rover was moving, or had they mounted the rover on a system which was allowing it to shake a little? On this sequence, the seated astronaut and the low-gain antenna are seen under this angle of view. But the camera, which is supposed to film this scene, is located almost in the centre of the rover, at the place which is circled. And this camera would see the astronaut under the angle of view which is shown here. It would see the astronaut less in profile, more frontally, and it could not see the astronaut and the low-gain antenna at the same time. Besides, if we look in the reflection of the astronaut's visor, we can see that the camera is not currently pointing at the astronaut. And the stuff which is in front of the astronaut is not even correctly positioned on the visor. It appears too much on the left. It should rather appear positioned in this way. To conclude with this sequence, on the animation made from this sequence, you can see that the reflection of the other astronaut's head on top of the visor. But why does the reflection appear on top of the visor while it should appear lower instead? One should have to be seriously deluded to think that this sequence has been filmed on the moon. And, unlike what the Apollo believers are asserting, the delay of communication between the Earth and the moon is not always respected. Given the distance of the moon to the Earth, 384,000 kilometers, and the speed of the light, 300,000 kilometers per second, it takes 1.25 seconds for the light to go from the Earth to the moon, and vice versa. Slightly more than 1.25 seconds, but we'll round it down to 1.25. Thence, the time of transmission of radio waves from the Earth to the moon, or from the moon to the Earth, cannot be less than 1.25 seconds. It is even slightly more, for the waves can be slowed down a little in Earth's atmosphere, but we'll neglect that. When the operator asks a question to an astronaut, it takes 1.25 seconds for this question to reach the astronaut. The astronaut hears it and answers to it. The answer takes another 1.25 seconds to reach the Earth where it is recorded. So, between the question of the operator and the corresponding answer of an astronaut, there must be a delay of at least 2.5 seconds. But if this delay is generally respected, it is not always, and when it is not respected, It proves that the astronaut is not answering from the moon. Sometimes there is even a joke about this delay, as you're going to see two of them. At the time of 142 hours, 49 minutes and 5 seconds into Apollo 17, we find the following dialogue. Parker says, "OK, and John suggests that we might just check it momentarily whilst you're here to make sure it's still holding on good and tight, both the clamps and the tapes." Cernan replies, "Yeah, that's on my list." It makes no doubt that Cernan answers to the last part of Parker's phrase, because he's had to know what items Parker was talking about, the clamps and the tape, before saying it was on his list. If we decompose the dialogue, we see the following phrases. 1. Parker talks and says something to Cernan. 2. Cernan starts replying, but he replies less than 1 second after Parker has finished talking, and does not quite finish his phrase, visibly embarrassed. 3. Then we hear the end of the echo of Parker's voice. 4. Cernan makes his reply again, this time with the correct delay. This shows that the astronauts had to take care about respecting the communication delay. In fact, this is not really Cernan we hear, but the voice of an actor who impersonates him, for it is clearly not his voice. There is another example in which an astronaut is found replying too early, and the joke has even been pushed further. At the time of 169 hours, 28 minutes and 09 seconds, Parker talks to Schmidt and says, "Copy that, we've also got SCB-3 with the Rover samples in it on the Rover. If you have any, yeah, have you some of those today?" And Schmidt replies, "No, we emptied those into 5. It makes no doubt that Schmidt answers to the last part of Parker's phrase, for he had to know what those Parker was talking about before saying what he had made of them. If we decompose the dialogue, we see the following phrases. 1. Parker talks to Schmidt. 2. Schmidt immediately starts replying, but he just says "we" and stalls. 3. We hear a part of the echo of Parker's voice. 4. Schmidt starts replying again, but he is still too early and stops again after having said "we". 5. We hear the end of the echo of Parker's voice. 6. Finally, Schmidt says his full reply with a good delay of transmission. The 2 times that Schmidt replies early on the sound graph have been greyed, so this example is still funnier than with the example of Cernan, for Schmidt is not just early once on the delay of transmission, but even twice. Like for the preceding example, it is not really Schmidt we hear, but the voice of an actor who impersonates him, for it is not his voice either. To the moon hoaxers who say that the flag flaps in the wind on the videos, the Apollo believers reply that the flag only flaps out of the inertia when the astronauts plant it, and that after they have stilled it, it remains perfectly immobile. Someone has made a gif of the 2 photos of Buzz saluting the flag to show that the flag does not move at all between the 2 photos. But on the 2 photos of Apollo 11, we can see that the blue part with the stars is shaded in both sides. If it is shaded on one side, it logically shouldn't be on the other side. In Apollo 15, there is a sequence in which an astronaut passes before the flag without touching it, and this one starts swaying, apparently because of the move of air caused by the astronaut. An Apollo believer has made an animation to show that the astronaut could have touched it while he passed by. However, the flag of his demonstration is more turned than the flag of the video of Apollo 15, which shows that he has cheated. The flapping period of the flag can be calculated with the famous formula of the pendulum, using the flag's height as the pendulum's height and the local gravity. If we use the lunar gravity, we find a flapping period of 4.71 seconds. And if we calculate it with the gravity of Earth, we find a period of 1.91 seconds. If we measure the period of the flapping flag of Apollo 15, we find a period of around 1.9 seconds. The best to measure this period is to sample this sequence. Sampling it at 10 images per second is sufficient to have a good estimation of this period. So it makes no doubt that the flag is flapping on the Earth and not on the Moon. We have a reference on Earth which is the flag of the demonstration of Mythbusters. Indeed, if the Mythbusters have made the void in the chamber which they make the test, they have not replaced the gravity of the Earth, which is one of the Moon, so their demonstration does not really show how the flag would flap on the Moon. If the flapping of the flag of the demonstration of the Mythbusters is slowed down to show how it would flap on the Moon, it gives this. In fact, the flapping period of the flag of the demonstration of the Mythbusters is very close to the one of the flag of the Apollo 15, and the flapping period on the Moon is so different that there can be no confusion. Moreover, while the Mythbusters have insisted that the flag can flap for a long time in their demonstration, the flag of Apollo 15 stops quite fast to flap because of the friction of air. The Apollo believers also show the demonstration of the hammer and the feather as a proof that it is made on the Moon. An astronaut drops in the same time a hammer and a feather, and they reach the ground at the same time. On Earth, the Apollo believers point out that hammer would have reached the ground before the feather. Percy has made a demonstration which shows that a feather can fall as fast as a hammer, provided that it is dropped with the correct orientation. Anyway, nothing proves that it really is a feather, for we cannot distinctly see it. It could be anything, including a bit of plastic. In fact, what would really prove that these two objects really fall on the Moon would be that they fall according to the lunar gravity. But if we time this fall, we can see that it falls slower than it would do on the Earth, but in the same time a little faster than it should on the Moon. We find the solution of this riddle when we sample this sequence. This animation shows the sequence sampled at 10 images per second. On each image, a progress bar has been added, and it progresses at each image. You can see that on one image in 2, the progress bar moves while the image does not change. The explanation is simple. The fakers have inserted duplicated images in the sequence so that the objects would seem to be falling slower than they actually do. This way, the speed of the fall is artificially slowed down twice. And if we remove the duplicated images from the sequence, the two objects fall at Earth speed, which shows that the demonstration has been made on the Earth and not on the Moon. In Apollo 14, the astronauts have made an experiment with a pendulum of length of 0.09 meters that they have made beat for several times. They have counted 18 oscillations which elapsed on a period of 85.7 seconds, which makes an average period of 4.8 seconds for each beat. This demonstration was aiming to prove that the pendulum was beating on the Moon. In fact, the trick becomes obvious when we notice that each time the pendulum arrives on the right side, it gets stuck for a while in the stuff which is circled. It does not immediately come back like it normally should. This way, the astronauts are artificially slowing down the beat of the pendulum. If the pendulum was not remaining temporarily stuck on the right of each beat, it would beat at Earth period, not the Moon one. You'll notice that they have made their demonstration in such a way that it is easy to prove they are fake. They could have also done them by playing with the motion speed, in which case it would have been impossible to prove that they had been faked. And there are plenty of sequences in the videos of Apollo in which we can see the objects fall too fast on the Moon, like in this sequence in which Schmidt pours lunar dust into a bag that Cernan is holding, missing the bag, and the dust falls on the ground. If we time the fall of the dust, we can see that it falls at Earth speed and not the Moon one. A demonstration which is perfectly hilarious is a demonstration of the free falling bag. An astronaut throws up a bag and this one falls down relatively slowly. The Apollo believers reason that the bag was thrown in an environment without air, and compute that the way the bag falls down corresponds to the moon's gravity and not the Earth's gravity. But it is perfectly ridiculous, for if it falls down slowly, it's just because it's slowed down by the friction of air. Of course, the Apollo believers claim the bag has been leaded, but it's not absolutely the case. It's a perfectly normal bag, absolutely not leaded, and it falls down like a normal bag does on Earth. Now, the Apollo believers will say that even if the bag is not leaded, it cannot be proven it is not falling on the moon, for it is still falling at a slow speed in fact. Yes, it can be proven. It can only be falling on the Earth and not on the moon. Indeed, look at the way the astronaut is throwing the bag. He gives a rotation to the bag. If the bag was really falling on the moon, as there is no air to counter this rotation, the bag would keep this rotation to the end of its fall. Instead of this, you can see that the rotation of the bag stops before it has finished its fall, because this rotation has been countered by the action of air. And you can also see that the bag, instead of following a parabola like it should, ends its fall vertically. This undeniably proves that the bag is thrown on the Earth and not the moon. The Apollo believers also consider the video of the Grand Prix of Apollo 16 as a proof that has been made on the moon, for according to them, the dust which is ejected behind the wheels of the rover follows a perfect parabola. They must not have observed how the dust which is ejected behind a buggy on Earth behaves, because it also follows a parabola. It is not possible to compute this parabola, for it does not only depend on the gravity, but also unknown parameters, such as the force that the dust is ejected with. And on Earth, the resistance of air has an influence which is variable according to the weight of the ejected particles of dust. The lighter the dust and the longer the parabola will follow. And on this image extracted from the video, the dust cloud we see is not exactly a perfect parabola. And how could the hole we see through this dust be created, when we can even see the aslep through this hole? In fact, not only this sequence does not prove that it's been made on the moon, but it even proves the contrary. We are going to get interested in the moment that the lunar rover turns back after having ridden in the direction of the lunar module. The dialogue explains that the rover would have ridden at a speed which was not over 10 kilometers an hour during 25 seconds, which makes a little less than 70 meters. On the other hand, the lunar module is said to be at 800 meters away at that moment. So when the rover turns back, it is at less than 70 meters from the astronaut who takes the video, while the lunar module was at more than 10 times further away. And yet we have the feeling that the rover is very close to the lunar module when it turns back. The lunar module should definitely be farther in the background. Place an item at 70 meters from you and another at 800 meters from you, and you'll see if they look that close to each other. If we put the rover with the astronaut on it close to the lunar module, knowing their dimensions, this is what it'll give. The rover looks rather small compared with the lunar module, but this is when they are close together. On the video, when the rover turns back, it is less than 70 meters from the astronauts who takes the video, while the lunar module is 800 meters away. It means that the lunar module is more than 11 times farther away than the rover. So if we reduce by 11 the size of the lunar module to show how it should appear relatively to the rover, this is what it gives. Now the lunar module is consistently smaller than the rover. And if we make the rover pass before the lunar module, knowing that they are almost at the same height on the video, this is what we should see. The lunar rover manages to completely hide the lunar module. In reality, the lunar module, being much farther away in the background, should not appear so close to the lunar rover when it turns back, but should appear higher on the image of the video. And that's not all. The lunar module we see in the video looks very strange. What definitively shows that the lunar module we see in the video of the Grand Prix is abnormal is that its rendezvous antenna appears oversized relatively to the rest of the lunar module. In fact, this is not a real lunar module, but a clumsy toy instead. You'll notice that they make all their demonstrations in such a way that it's easy to prove that they are fake and not made on the moon. There is a famous demonstration that the Mythbusters have made to show that the relief could deviate shadows, and which was intended to prove that a photo of Apollo 14, which has been contested by the moon hoaxers, was in fact normal. You will notice that in all their demonstrations on shadows, the Apollo propagandists always use a close spotlight instead of the real sun, so they use invalid conditions from the start. Now, the demonstration of the Mythbusters has been inspired from a demonstration made by the Goddard Center, on which we better see the problem. They claim to have perfectly reproduced the rock of Apollo 14 and its little sister on the left, and they placed them on a little mound. They have put a marker pen close to the rock to show that its shadow is not parallel to the one of the rock. However, if the shadow of the marker pen effectively diverges less than the one of the lunar rock, it is not for as much as perfectly parallel to the one of the lunar module, because the source of light is too close. Once more, they are afraid of using the real sun. However, the demonstration of Goddard contains weak points which make that it does not really debunk the problems of the photo of Apollo 14. First, you can notice that on their photo, the shadow of the little rock is not parallel to the one on the bigger rock, while it is on the photo of Apollo 14. Then you can see that the shadow of their rock does not end the same way as the one of the rock of Apollo 14, whereas they admitted that they perfectly reproduced the rock of Apollo 14. While they wanted to prove that the photo of Apollo 14 was normal, they have to the contrary proven that it was abnormal. The Apollo propagandists also make a demonstration with a wire which becomes invisible when it passes over a white sheet, to explain why the crosshairs disappear on some photos when they pass over a white background. But this demonstration is completely invalid, for the wire of their demonstration can be attacked under a wide angle by the white background. While the crosshairs are built inside the camera and the white background cannot erase them, for it can attack them on a much too narrow angle to make them disappear. If the crosshairs could disappear that easily, they would not be very useful, and the explanation of the film's emulsion, which can also make them disappear, does not hold either, for if that was the case, the image would be blurred, and it is very clean. The Mythbusters have also made a demonstration with a very close spotlight again, and a very reflective ground, to show that the reflection of the lunar ground could light Buzz Aldrin as he descends the ladder in Apollo 11. But their demonstration is not very convincing. While their background is more luminous than the one of the photo of Apollo 11, their astronaut appears darker than Buzz Aldrin on the photos of Apollo 11. And if we change the luminosity of the photo to make the luminosity of their ground closer to the one of the photos of Apollo 11, their astronaut appears still darker, much darker than Buzz Aldrin on the photos of Apollo 11. So, they have not really proven that the photos of Apollo 11 were normal. We can call it a fail. Then comes NVIDIA, which triumphantly announces that it has solved this problem with a demonstration using its super graphic card. And the media don't hesitate to publish NVIDIA has debunked the moon hoax, like it was the only problem. And after this problem has been debunked, the moon hoax is definitely completely debunked. According to NVIDIA, it is the sunlight reflecting on the suit of Armstrong which would provide the necessary luminosity to light Buzz Aldrin like what we see on the photos of Apollo 11. So, according to NVIDIA, the suit of Armstrong could work like a mirror. And with the assumption of NVIDIA, it has made a brilliant demonstration with its super graphic card showing that it contained the same result as on the photos of Apollo 11. But the assumption that the astronaut's suit could reflect the sunlight like a mirror is outright wrong. If it could reflect the sunlight this way, then this astronaut, which is frontally taken in space with the sun in front of him, would send back so much light that it would be impossible to photograph it. And If it is true that Armstrong's suit can reflect light so that it can light Buzz Aldrin like what we see in the photos of Apollo 11, then why does he appear so dark on the video which films him while he descends the ladder, as dark as Armstrong when he himself descended the ladder? The Apollo propagandists also point out, with the total number of people who have worked on the Apollo project, that it would not have been possible to keep the secret. Someone would have necessarily talked out to expose the hoax if there had been one. But the Nazis managed to keep the secret of what was happening in their death camps, and none of the Germans outside of the camps were aware of it, and they were much more numerous than the people who worked on the Apollo project. Moreover, most people worked on a Saturn rocket, only a small minority worked on the lunar path. And the project was compartmentalized. Everybody only knew what he was needing to know and no more. You don't imagine that NASA sent a memo to the whole personnel to warn them that it would fake the project, do you? And yes, there were people who knew, those who were necessary to make the hoax work. But after what happened to Thomas Barron, who paid it with his life after he publicly exposed the conditions of the tests of Apollo 1, nobody was willing to imitate him and take the risk of exposing the hoax. But that does not mean that they didn't talk out, not directly of course. It was too dangerous. One would have been suicidal to do it directly, but indirectly by stuffing the project with hints, hoping that there would be people who would see these hints and who could expose the hoax for them. There are hints of the hoax everywhere in the project. All the photos contain anomalies, and the photos contradict each other, and the photos and videos also contradict each other. The Apollo believers think that they have debunked the problems of converging shadows by showing examples of converging shadows. But these examples don't explain everything, for on all their examples, the shadows meet on a common point. While on plenty of photos of Apollo, and notably in Apollo 15, the shadows don't meet on a common point, but different points instead. All the electronic interfaces of the technical documentation contain intentional errors. For instance, on this schematic of a digital multiplexer, only the first stage is normal, and shows how all the other stages should be made. On all the other stages, the entry diodes are missing, and this makes that the digital multiplexer cannot normally work. And this is just an example among hundreds of other ones. And the program of the AGC is nothing but a heap of nonsense. Redundant instructions, useless instructions, illegal instructions. There is even an infinite loop and a division by zero. And the program never tries to guide the spaceship. It does not even try to display anything on the diskette. The jokes are not only in the comments that everybody can understand, they are also in the program code that not everybody can understand. The Lunar module could work with fantasy comments and a serious code, but it cannot work with a fantasy code. This program shows the art of writing plenty of code, which does absolutely nothing. All the programs of the AGC are available online, like this program, the ignition routine, baptized Burn Baby Burn, which does nothing apart from setting the engine on. And the programmer's manual is also online. It allows to have the full description of the instruction set of the AGC, and also the description of the macro instructions. With this manual, an experienced programmer can read the program of the AGC and understand what they do. And there are such experienced programmers amongst the moon hoaxers. For the serious moon hoaxers, not the flat earthers of course, of believers of other nonsense, are among the most educated people, unlike the propaganda wants to make believe. And about the astronauts, they have also been forced to lie? They don't seem so. They seem sincere when they say they walked on the moon and outraged when accused to lie. For the astronauts, it has not been necessary to threaten them not to admit they did not walk on the moon, for another method was used for them. In the 60s, the CIA had developed, in the scope of the Paperclip project, a special program of mental manipulation called MK Ultra. This program was using hypnosis and LSD, and it was allowing to make anybody submitted to it to believe things which were not actually true. This program was illegally tested on soldiers and prisoners. In fact, it was not possible, like some think, to let the astronauts go in space and orbit the Earth for the time of the mission, for it would have been impossible to make them believe that they had walked on the moon. What really happened is that, just before the lift off the Saturn rocket, the astronauts who had been seen entering it were put to sleep and secretly extracted from the rocket. Then they were put into a space capsule, which could be the capsule they used for their training, in which they could believe to be flying towards the moon. Then they were submitted to the mind manipulation program to make them believe they were walking on the moon. In the last magazines of Apollo 17, there are photos which clearly show the astronauts in a second state, which is a fixed stare, a strained face. They were certainly submitted to the MK Ultra program, drugged with massive doses of LSD. That's why it was totally useless from Bart Sibrel to try and make the astronauts confess they did not walk on the moon. You cannot make someone confess something when he really believes in it. All he reaped was violent reactions from the astronauts, which contributed to make believe that they were not lying, and that Bart Sibrel was trying to extort from them an imaginary confession. Bart Sibrel had it all wrong. The right manoeuvre was not to accuse the astronauts of lying, but to pretend to believe them when they said they landed on the moon and walked on it, be nice with them, and ask them information about how they went to the moon, landed on it, and lived on it. For you could then show that what they said is total nonsense. Like Alan Bean, who, when questioned about the Van Allen belts that he is supposed to have gone completely through, was not even known their existence, and could not report any of its effects, while astronauts who have gone close to them but without entering them have reported very special effects, like shooting stars before their eyes. Or Alan Bean explaining that they could stand the extreme heat inside the lunar module because they were provided with a cooling system powered by batteries, which is a total ineptitude, for first air conditioning could not work on the moon, and then batteries would not last long if they were not kept charged. Or like Buzz Aldrin and Michael Collins saying in the movie In the Shadow of the Moon, that when the Saturn rocket lifted off, they could feel the rocket sway because, according to them, the gimbaling system of the rocket was looking for the centre of the mass of the rocket. This is in fact a total nonsense, for the gimbaling system is pre-adjusted before the liftoff, so that the thrust of the engines is already perfectly aligned with the centre of mass. When the rockets lift off, we can see that it remains perfectly straight as it ascends. It does not sway at all. And all along the flight, the gimbaling system is continuously adjusted so that the thrust remains aligned with the centre of mass and the rocket never sways. If the gimbaling system was not already adjusted at liftoff, it had to look for the centre of mass as the rocket ascends. As the astronauts of Apollo 11 suggest, the rocket would be so unstable that the gimbaling system would not even have the time to find the centre of mass of the rocket, and the rocket would crash shortly after the liftoff. In the same movie, Cernan said that he descended a slope on the moon with the rover at a speed of 17 km per hour, which he asserted was the greatest speed ever recorded on the moon. But we can wonder how he could be so precise, for the speed indicator was rather small and graduated from 5 to 5. It was not displaying the units of speed. And what shows that he is making that up is the dialogue of Apollo 17. They explicitly say that the record speed coming downhill was 14 to 15 kilometers per hour. And in the same movie, Michael Collins observes the lunar module which is coming back at the command module and describes it as a small golden insect which progressively grows. The way that Collins sees the lunar module coming back, the lunar module appears approaching the command module this way. It constantly remains at the vertical of the command module. But in fact the lunar module should not approach the command module this way, but this way along a parabolic trajectory. It should pass over it and arrive on the orbit of the command module a little ahead of it. It means that Collins would only see the lunar module when it is relatively close to the command module. The astronauts like Armstrong in a public presentation also often talk about piloting the lunar module like a helicopter by pitching it. The movies which show the lunar module flying over the lunar surface make the same mistake. In reality, the flight of the lunar module over the lunar surface has absolutely nothing to do with the flight of a helicopter. When a helicopter moves forward, it bends its main blades, which generates two air forces. The vertical one allows to sustain the helicopter in the air, and the second one allows a horizontal move of the helicopter. The speed that the helicopter is moving forward depends on the slant of the blades. But in the void of the moon, there is no air to provide a force which would counter a lateral move of the lunar module. If the lunar module was pitching and was being pushed by its main engine, as there is no force to counter the horizontal move of the lunar module would constantly accelerate and would very rapidly reach a speed which would be incompatible with looking for a spot to land on. That means that the lunar module cannot absolutely behave this way to move over the lunar surface. In fact, when the lunar module is flying over the lunar surface, it must be vertical so that the main engines counter the lunar attraction, and it must move by using its lateral thrusters, even if the lateral thrusters are less powerful than the main engine, as there is no force to counter the lateral move of the lunar module. They are also able to reach any speed. The only difference with the main engine is that they will take more time to reach a given speed, but they will also manage to reach it, whatever this given speed is. In fact, to move in one direction, the corresponding thrusters must be fired, but not permanently. If the lateral thrusters were permanently fired, they would indefinitely accelerate the lunar module, which could reach a very important speed, also incompatible with looking for a spot to land on. The lateral thrusters must only be fired the necessary time to reach the desired speed. Once the desired speed is attained, they must be shut off, otherwise they will continue to accelerate the lunar module. In order to stop the lunar module, the opposite thrusters must be fired, and only the necessary time to stop the lunar module. As the lateral thrusters could not be throttled, and the accuracy of their commands was rather rough, it was probably not easy for the lunar module to attain a total immobility. When Charlie Duke was interviewed by James May and asked how they were managing to orientate themselves with the rover and find their way back to the lunar module without a magnetic compass, Charlie Duke answered that they just had to follow the rover's tracks back to the lunar module. Charlie Duke was not even knowing that the rover was equipped with maps circled in red on this close-up of a photo of Apollo 15, and a solar compass circled in green on the same close-up. And if they were following the rover's tracks to go back to the lunar module, how were they doing when their circuit was making a loop, like in the EVA of Apollo 16, and they were not coming back the way they went? In his article, Tales About the Lunar Module Guidance Computer, Don Iles says this about the 1202 alarm. On board, Aldrin saw the prog light go on and the display switched back to the verb 06 noun 63. He quickly keyed in verb 5 noun 9. Alarm code 1202 appeared on the disk key. But in the video, hear Buzz Aldrin tell the story of the first lunar landing. Buzz Aldrin explains that when the 1202 alarm happened, the lines of the display were suddenly blanked by the alarm. It is strange that Buzz Aldrin does not remember what he had to do to make the code of the alarm appear on the display of the disk key. In fact, there were two astronauts who seemed to have doubts, unlike the other astronauts. It was Neil Armstrong and Pete Conrad. They could only have doubts, not certitudes, for they had been submitted to the MK program like the other astronauts. Neil Armstrong and Pete Conrad had more reasons to doubt than the other astronauts, for they were the only astronauts who had flown on the training vehicle, and they could see how unstable and dangerous it was. Armstrong almost lost his life in one of the trainings. In the movie In the Shadow of the Moon, Neil Armstrong was the only astronaut of the still living astronauts who refused to participate in the movie. Yet, he would have been the central star of this movie as being the first supposed man to have ever walked on the moon. In 2012, a surgical operation was performed on Armstrong, a heart bypass, in fact a rather common operation which almost always succeeds. He did not directly die from this operation, but from very bad post-surgical care. Some people felt very indignant about this bad post-surgical care and said a hero like Armstrong was deserving better, and even outright accused the doctors of having killed Armstrong. Wouldn't someone like Armstrong, considered a national hero, have deserved a better surgical care? Von Braun is generally considered the father of the Apollo program, and nobody doubts that Apollo would not have existed without him. He is believed to have fathered the program of the V-2 rocket, this destruction weapon that the Nazis were hoping that would change the fate of the war. But, in fact, the truth is that von Braun was in fact a mediocre engineer, and he didn't make brilliant studies. He is not the real father of the V-2 rocket. He used the competencies of engineers who are much more talented than him, in particular an engineer by the name of Schroeder. But, unlike von Braun, Schroeder didn't have the favour of the Nazi regime, for he was not a Nazi, and he had never joined the Nazi party. There is no known photograph of him, like he had to remain hidden. On the other hand, von Braun was a Nazi dignitary, here, close to Himmler. So it was not difficult for him to attribute to himself the merit of the V-2 program, for the Nazi government was certainly preferring a good Nazi to be the father of this program, rather than someone who refused to join the Nazi party. While von Braun was taken to the US immediately at the end of World War II, and even before, Schroeder was held prisoner for several years after this war. Schroeder has explicitly accused von Braun of being an opportunist who picked the brains of better men and grabbed credit others should have had. A researcher, Mentz, found letters Schroeder wrote warning American authorities of mistakes von Braun was making, which he said could hinder the development of rocket technology. If Schroeder was not guilty of war crimes, it was not the case of von Braun. Von Braun worked in the camp of Dora, in which the Americans found 20,000 corpses lying on the ground when they liberated it, and, although von Braun said that he was unaware of the way that the prisoners were treated, testimonies of prisoners say otherwise, like the testimony of a prisoner who said that he saw von Braun pass by the piles of corpses without showing the least emotion. Arthur Rudolph and von Braun were wanted in Nuremberg for their crimes. The Americans spared them the trial by moving them to the US. Fritzl Sokol had been sentenced to death and hanged in Nuremberg for his participation in the forced labour in Germany. But those who were employed in this forced labour were decently treated and could come back alive, while those who worked in Dora were treated in the most inhumane way and were dying while working, reduced to the state of skeletons. When Speer visited the camp of Dora, he was so much startled by the inhumane way that Rudolph was treating the workers with that he demanded Rudolph to improve their conditions, what Rudolph completely ignored and went on treating them inhumanely and making public executions. So, if Sokolov deserved death, Rudolph and von Braun were still more deserving of it, and it makes no doubt that they would have been hanged in Nuremberg if the Americans had not spared them the trial. but the difference with Sokol is that the Americans had no use of him, while they could have had a use of von Braun and Rudolph for monitoring the rocket program and the scope of the future American space exploration. In the 80s, there was a lawsuit against Arthur Rudolph for his responsibility in the genocide of Dora, and he had to flee Germany to avoid the trial and not end his life in an American prison. Von Braun avoided this trial, for he was already dead. So, for what reason NASA would have preferred to use the services of a mediocre engineer rather than the ones of the brilliant engineer that Schroeder was? It was certainly not for his talents in rocket technology. If Schroeder had been at the head of the Apollo program, as he didn't have war crimes on his conscience, it would have been difficult to force him to cooperate in a fraud. It was much more different with von Braun, who was guilty of war crimes. The CIA could weigh on him and force him to cooperate by offering him its protection against lawsuits for his criminal behaviour during the war, provided that he would allow the fake project to exist. This shows that the CIA had decided to fake the space program, at least a part of it, from the start. And is the astronaut Don Petit credible when he says that NASA has lost the technology of Apollo and that it would be a painful process to build it again? Oh really? How is that possible to lose a so fantastic technology? Are there any examples of an outstanding technology which has been lost? The Concorde has had a terrible accident, and since then it has stopped flying. But it does not mean that its technology has been lost. If Aerospatial was told to build one again, and that it could fly, it could perfectly build it again. It has not lost its plans. And NASA also claims it has lost the telemetry tapes of Apollo 11. But how is it possible to lose the tapes of a so great unique event? The Wright brothers had to make many tests and broke many planes before managing to make their plane fly in a safe way, which allowed the development of aviation. Ariane had many fails before managing to put a satellite in orbit, but once it managed to learn the technique, it almost always managed to put them in orbit. But Apollo 11 would have managed to make a lunar module land on the moon at the first attempt, though it had never been tested before. The tests on Earth were only consistent in making a training vehicle fly over the ground at low altitude and relatively low speed, and moreover with a computer which had multiple alarms. It is simply not credible, even if the lunar module and the AGC had been normally conceived. And the most improbable scenarios are produced in the mission, like Buzz Aldrin allowing the lunar module to lift off by changing a broken circuit breaker with a felt-tip pen. Oh really? A felt-tip pen? Couldn't they have been provided with a screwdriver to do the job? Or was a screwdriver considered too heavy to be used in the mission? And the most ironic is that the circuit breaker which had to be changed was close to two other circuit breakers which were found to be in the up position. So, if an astronaut brushed the command panel with his backpack and broke the circuit breaker, if he set these circuit breakers to the up position, it is more than obvious that he also set the engine arm circuit breaker, which was just close to them, to the up position, and it had to be in that position for the liftoff. So in fact it appears that the circuit breaker was already in the correct position, and thence Buzz had nothing to do to allow the liftoff. So this comedy with a felt-tip pen was just for show. And the missions are filled with miracles. When the rover was deployed from the lunar module, it almost was a naked chassis. All the equipment had to be put on it, and the astronauts had to do it with their pressurized gloves and the poor vision they had with their visor, which was not even allowing them to see through the viewfinder of their camera. We don't see them do all the work on the videos, which would have helped us to believe that they could do so an improbable work. No doubt that they benefited from a magical help, operators making the job for them on the fake moon set. And couldn't have they found a more practical system to adjust the Aslep's antenna than a water bubble which got stuck in Apollo 17? And it is only in Apollo that someone would try to fix a knocked off fender with duct tape, put on ski gloves which are much easier to manipulate than the big pressurized gloves of the astronauts, and try and use duct tape, and we would really be surprised if you managed to do it. And the way we see the astronauts do it on the video, it would be surprising that it could work. We can also wonder how the astronauts managed to damage a rear fender, for we would rather have expected a front one to be damaged instead. Anyway, the astronauts are really talented if they manage to fix the damaged fender with duct tape, especially with their pressurized gloves. But they are heroes, aren't they? And the astronauts are so much heroes that they can even breathe on the moon without their backpacks. On this photo of Apollo 12, the one that Phil Plait so much admires, while we can clearly see the ops, the top of the backpack, behind Albin's head, it's been coloured in pink, we cannot see it behind the head of Pete Conrad in the reflection of the visor. If he has one, it is abnormally small. And seriously, if you had been on the moon and you had known that the least rip to your suit would have caused your death, would you have carelessly behaved like the astronauts making the clowns on the lunar surface? Some have called them heroes, but this is not courage, this is temerity. This is temerity, and temerity is not courage, temerity is foolishness. When you make such a mission, dangerous and never made before, you don't take such chances. If it is fake, on the other hand, you can mess around as much as you want. You won't die from falling around. And is this astronaut's suit we see on a photo of Apollo 16 really suited for the very hard conditions on the moon? And frankly, on this photo of Apollo 14, is this really lunar dust, the thin dust that Armstrong had talked about? Kennedy had decided that men would land on the moon before the end of the decade, and although the engineers tried to make him understand that it was not possible to make it in so short a time, if ever it was possible, they were left no choice. If it could not be done for real, then it would be fate, whether they liked it or not. And woe to anyone who would try to expose the hoax. The goal was too important to allow anyone to make it fail. So the hoax went on, and when the astronauts walked on the so-called moon, everybody saw it on television. And it had to be true, for people could see it on television. And when some people started to doubt these miraculous landings, the propaganda went into full gear to counter these doubts with so-called proofs, lousy demonstrations, and simplistic arguments. And to those who say that if Apollo had been fake, it would have already been exposed by now, we'll remind them that more than 1 century after Galileo's death, his heliocentric theory was still banned and considered false. The truth often follows a long and tortuous path, but it always finds its conclusion.